Throughout the extensive chronicles of human history, few endeavors have stirred the collective imagination and propelled the course of humanity forward as powerfully and profoundly as the iconic Apollo 11 mission. This monumental feat of exploration and courage, which unfolded during the summer of 1969, remains one of the most remarkable and inspirational chapters ever written in the annals of human achievement. Apollo 11 was not just a mission. It was a bold leap into the unknown, a symbol of humanity's relentless curiosity and unyielding desire to transcend earthly boundaries. It marked the first time mankind set foot on a celestial body beyond our planet, the Moon. Against a backdrop of intense geopolitical rivalry, scientific ambition, and technological innovation, 3 brave astronauts embarked on a journey that would captivate the world and forever change our understanding of what was possible. The mission epitomized the culmination of years of painstaking research, dedication, and an extraordinary collaborative effort involving thousands of engineers, scientists, and visionaries. Neil Armstrong, Buzz Aldrin, and Michael Collins, names that have since become synonymous with courage and discovery, etched their legacy in history by achieving the first successful manned lunar landing. As Armstrong famously declared, "That's one small step for a man, one giant leap for mankind." Those words echoed the hopes and dreams of millions. Apollo 11 was more than a scientific expedition. It was a unifying moment for humanity, inspiring generations to look beyond our blue planet and dream bigger, reach farther. In reflecting on this cosmic odyssey, we are reminded of the power of human determination and the enduring spirit of exploration that continues to drive our quest to understand the universe around us. The story of Apollo 11 is not just about reaching the moon. It's about the boundless potential of mankind to push the limits of knowledge and boldly venture into the great unknown. While many remember Apollo 11 primarily for its triumphant lunar landing and Neil Armstrong's immortal words echoing across the silent expanse of space, there exists a shadowed narrative, a story far less told and often overlooked, nestled quietly within the mission's grand timeline. This is the tale of Michael Collins, the unsung hero of Apollo 11, whose role in the monumental lunar saga was nothing short of pivotal, yet whose legacy has remained shrouded in relative obscurity. Today, we set out on an expedition into the forgotten corridors of history, guided by Michael Collins himself. Through his eyes, we will uncover a fascinating collection of secrets, stories both curious and captivating that shed new light on the Apollo 11 journey to the moon's distant and desolate surface. While Armstrong and Aldrin took the historic steps onto the lunar soil, Collins remained in solitary orbit aboard the command module, circling the moon alone, entrusted with the critical task of keeping the spacecraft safe and ready for their return. His was a lonely vigil, filled with equal parts tension and responsibility as he maintained the lifeline between the Earth and those who dared to walk on the moon. Often called the forgotten astronaut, Collins was anything but forgotten in the hearts of his fellow crew members and those who understand the immense demands of spaceflight. His steadfast commitment, calm resolve, and expert piloting were essential to the mission's success, a true testament to the fact that exploration is never the work of one alone, but the achievement of many. As we journey through Michael Collins' story, we'll reveal the human side of space exploration, the fears, hopes, and quiet heroism that accompanied him in the vast loneliness of lunar orbit. His reflections provide a unique perspective on one of humanity's most extraordinary adventures, reminding us that sometimes the most profound contributions happen behind the scenes, away from the spotlight. Join us as we unlock this hidden chapter of Apollo 11, celebrating the courage and dedication of Michael Collins and rediscovering the deeper layers of a mission that redefined the limits of possibility for all humankind. And what of the mysterious far side of the moon, the enigmatic realm that has long beckoned humanity with its silent secrets? It raises an intriguing question. Why, after decades of quiet reticence, did Michael Collins choose this very moment to reveal the cryptic experiences he kept locked away for so long? What unknown events or revelations on the lunar surface compelled this stoic astronaut to finally share these concealed truths, hidden deep within the cosmic expanse? Join us as we journey further into this captivating narrative, peeling back the many layers of mystery that Michael Collins gradually uncovers about Apollo 11's extraordinary lunar mission. His reflections open a window into moments never before fully explored, moments that challenge our understanding of that historic voyage. Of course, no recounting of Apollo 11 would be complete without revisiting the immortal words of Neil Armstrong, spoken as he took humankind's first steps onto the moon's desolate surface. Each syllable echoes with the profound weight of the moment, etching itself indelibly into the collective memory of our species. A testament to human courage, curiosity, and the unyielding drive to explore. Yet, behind those iconic words lies a deeper story, one woven with suspense, solitude, and secrets, that only now begins to come to light through the voice of the mission's often overlooked guardian of lunar orbit, Michael Collins. That's one small step for man, one giant leap for mankind. These iconic words, spoken against the desolate and barren backdrop of the moon's surface, perfectly captured the monumental significance of that historic moment. Buzz Aldrin soon followed in Neil Armstrong's footsteps, as the two brave astronauts boldly ventured onto the lunar terrain, forever etching their names into the annals of history. Meanwhile, Michael Collins held a role just as critical, though often overshadowed and underappreciated. Serving as the vigilant guardian of the command module Columbia, he orbited the moon alone, ensuring the safe return of his comrades as they embarked on their extraordinary cosmic exploration. The moon itself has captivated humanity's imagination since the dawn of consciousness. For millennia, it has been a symbol wrapped in mystery and awe. Long before the invention of telescopes or modern scientific instruments, our ancestors gazed at the moon with wonder and curiosity, crafting stories, myths, and calendars around its phases and light. For centuries, humans meticulously tracked the moon's phases, unraveling the intricate rhythms of lunar eclipses and weaving rich myths and legends around its silvery visage. Early sky watchers intuited the moon's powerful influence on Earth's tides and pondered its mysterious effects on human psychology and behavior. The first probes sent to the moon were unmanned. Soviet lunar missions and the American Ranger and Surveyor programs paved the way. These early robotic explorers returned invaluable data about the lunar surface, geology, and environmental conditions. With every new discovery, humanity's fascination deepened, fueling a growing determination to send humans to walk on that distant, enigmatic world. This ambition intensified dramatically during the Cold War, as the United States and the Soviet Union engaged in a fierce competition for space supremacy. The race to the moon became a symbolic battleground for national pride and technological prowess. In response, the United States launched the Apollo program in 1961, a bold and resounding commitment to land a man on the moon and return him safely to Earth. This bold affirmation of our determination to send humans to the moon and return them safely before the decade's end demanded unprecedented resources, ingenuity, and coordination. The Apollo program encompassed a multitude of developmental and testing stages, each progressively more complex. These included suborbital and orbital flights to test spacecraft systems, intricate rendezvous and docking maneuvers in Earth orbit, simulations of lunar orbit and descent, and the pioneering art of extravehicular activities, EVS, all essential milestones leading up to the moon landing. The zenith of the Apollo program was the historic Apollo 11 mission, which embarked on its celestial journey on July 16, 1969. As the world watched with bated breath, on July 20, 1969, the lunar module Eagle descended gracefully onto the moon's dusty surface. The triad of adventurers, Neil Armstrong, Buzz Aldrin, and Michael Collins, has successfully entered lunar orbit. And as Armstrong began his descent to the surface, history was poised to be rewritten. At precisely 2:56 a.m. GMT, Neil Armstrong took that momentous small step, leaving his indelible footprint on the lunar regolith and uttering the immortal words that resonated across the globe. That's one small step for man, one giant leap for mankind. Shortly after, Buzz Aldrin joined Armstrong, and for nearly 2 riveting hours, the duo conducted scientific experiments, collected lunar samples, and documented their surroundings with photographs and video. This extraordinary feat symbolized not just a technological triumph, but a profound milestone in humanity's quest to explore the cosmos, one that inspired generations and expanded the horizon of what was deemed possible. They collected samples and etched their mark in history. The mission reached its climax with the planting of the American flag on the lunar surface, a powerful symbol heralding their triumphant achievement. After completing their historic moonwalk, Armstrong and Aldrin reunited with Michael Collins in the command module Columbia to begin their journey home. On July 24, 1969, they safely splashed down into the Pacific Ocean, completing an epoch-defining voyage. The adulation and celebration that greeted these fearless explorers upon their return reflected their immense valor and the indomitable human spirit. They had transformed the dreams of countless generations into reality and ignited a new era of space exploration. Yet, amid this triumphant narrative, Michael Collins, the often overlooked astronaut, played an indispensable and heroic role. As the command module pilot, Collins carried the vital responsibility of safeguarding their lifeline. He meticulously monitored and maintained all spacecraft systems, ensuring their flawless operation throughout the mission. His role was critical during the lunar module's docking procedure, a moment demanding absolute precision and expertise. One small error could have had catastrophic consequences, jeopardizing the mission and the lives of his fellow astronauts. Beyond this, Collins ensured the smooth functioning of all command module systems, including life support, communications, and propulsion. He was instrumental in relaying lunar photographs and observations to mission control, bridging the gap between Earth and the distant moon. Without his steadfast vigilance and skill, the success of Apollo 11 might have been impossible. Facilitating real-time insights into the moon's composition, Michael Collins' role transcended that of a mere technician. He served as the vital conduit between the lunar explorers and mission control on Earth. While Neil Armstrong and Buzz Aldrin made their historic lunar excursion, Collins ensured that every photograph, every observation, reached Earth swiftly and accurately, providing scientists and mission planners with invaluable data. Collins's responsibilities extended beyond communication. His role during the Trans-Earth injection maneuver was equally critical. This complex operation involved firing the spacecraft's engines to escape lunar orbit and plot a precise trajectory back to Earth. The successful execution of this maneuver was absolutely paramount to the astronaut's safe return, and Collins's technical skill and composure under pressure were the linchpin of this success. Despite the seemingly understated nature of his role, Collins embodied the true spirit of teamwork and camaraderie. He personified the collaborative ethos that underpinned the Apollo 11 mission, from its inception to its triumphant conclusion. However, it was in the solitude of space that Collins's story takes a profound and intriguing turn. While orbiting the moon's far side, he experienced a degree of isolation unparalleled in human history. The moon's unique radio-blocking properties severed his communication links with both his fellow astronauts and mission control, leaving him utterly alone in the vast expanse of space. In that profound silence, Collins confronted the immense loneliness and responsibility of his task, a solitary vigil that few have ever endured. In those moments of radio silence, Michael Collins was the only human being in the entire cosmos. A profound and almost unimaginable isolation. The moon's far side, as Collins poetically described it, is a realm of serene solitude. Unlike the familiar near side, this hidden hemisphere absorbs radio waves, effectively cutting off any communication and plunging Collins into complete silence. Yet, despite the eerie quiet, Collins recalled these moments not with loneliness, but with a sense of calm and tranquility. Adrift in the vast darkness of space, separated from all earthly voices, he found unexpected solace in introspection. Unlike the Apollo 8 crew, who orbited the moon together and shared radio silence collectively, Collins was the first human ever to orbit alone behind the moon's far side, granting him a uniquely solitary vantage point. From this isolated perch, he observed Earth itself, a fragile blue orb suspended in the vast emptiness of space, cut off from terrestrial transmissions and human contact. In that moment, Collins experienced a powerful perspective on humanity's place in the universe, a humbling and profound reminder of both our vulnerability and resilience. The moon's far side, untouched by the radio interference that continuously plagues its near side, offers astronomers a pristine sanctuary of radio silence. This cosmic quietude arises from the absence of human-generated radio frequencies, creating an unparalleled environment ideal for radio astronomy. Unlike Earth, which buzzes incessantly with signals from radios, television broadcasts, mobile networks and satellites, the far side of the moon remains shielded, allowing faint signals from distant celestial bodies to be detected with unprecedented clarity. This silence transforms the far side into a natural observatory, free from the cacophonous noise that hampers radio observations on Earth and the moon's near side. The near side, perpetually facing Earth, is engulfed in a relentless storm of radio frequency interference, making it a daunting challenge for astronomers to isolate weak cosmic signals. In stark contrast, the far side's radio quietness acts as a cosmic refuge, inviting scientists to peer deeper into the universe. The allure of the moon's far side has not gone unnoticed by the global scientific community. In 2019, China's Chang'e 4 mission made history by landing a robotic rover in the Von Karman crater, located within the vast South Pole Aitken Basin on the Moon's far side. This landmark mission was the first ever to explore this hidden lunar hemisphere up close, deploying a rover specifically designed to conduct low-frequency radio astronomical observation. Operating via a relay satellite stationed at the Earth-Moon L2 Lagrange point, the rover enabled continuous communication, despite the far side's natural radio blackout. By venturing into this unexplored frontier, the Chang'e 4 mission opened new windows for studying the universe's earliest epochs and cosmic phenomena otherwise obscured by Earth-based interference. The far side's unique radio environment is invaluable for investigating faint radio waves emitted by distant galaxies, cosmic microwave background radiation, and even signals potentially linked to dark matter and other cosmic mysteries. Beyond its exceptional radio quietness, the Moon's far side holds another significant advantage. It lacks a substantial ionosphere. Earth's ionosphere, a charged layer high above the planet's surface, often absorbs or reflects incoming cosmic radio waves, complicating radio astronomy efforts. Without this ionospheric layer, the Moon's far side provides a clearer, less distorted view of the universe's radio frequency landscape, enhancing the potential for groundbreaking discoveries. As humanity continues to explore and understand this remote lunar region, the far side stands as a beacon of scientific promise, a natural radio observatory poised to unlock secrets of the cosmos previously beyond our reach. Its silent expanse invites us to listen carefully, free from earthly noise, to the whispers of the universe. The presence of Earth's ionosphere presents significant challenges for astronomers, as this charged layer in the upper atmosphere absorbs or reflects many cosmic radio signals, complicating efforts to detect faint celestial emissions. In contrast, the Moon's far side is almost entirely free of such interference due to the near absence of a substantial ionosphere, making it uniquely suited for radio astronomy. This rare celestial seclusion allows for the detection of weak cosmic signals without the usual terrestrial hindrances that plague Earth-based observations. During his solitary orbits around the Moon's far side, Michael Collins experienced this unique vantage point firsthand. From his vantage in the command module, he gazed upon the Moon's enigmatic visage, a stark, cratered landscape untouched by human presence or eyes. His view was unlike any other, marked by the mesmerizing sight of Earth rising over the lunar horizon. This breathtaking spectacle revealed our planet as a fragile, azure orb suspended against the vast cosmic backdrop. The profound emotions stirred within Collins by witnessing Earthrise left an indelible mark on his soul. Seeing Earth from such a remote vantage underscored both the vulnerability and interconnectedness of all life on our home planet. Suspended in the vast cosmic sea, Earth appeared simultaneously minute and precious, a delicate jewel adrift in the immense darkness of space. This rare perspective, often referred to as the overview effect, transformed Collins's outlook on life and humanity. It imparted a deep, humbling understanding of Earth's place in the grand tapestry of the universe, emphasizing the planet's fragility and the shared responsibility of all who inhabit it. In the wake of this cosmic revelation, Michael Collins emerged as a passionate advocate for protecting Earth and promoting unity among its inhabitants. His unique experience orbiting the Moon's far side not only made him a witness to humanity's greatest journey, but also a powerful voice for safeguarding the delicate world we call home. Michael Collins became a passionate advocate for Earth's conservation, urging humanity to cherish and safeguard our fragile world. He cautioned against actions that threatened the delicate balance of nature and stressed the urgent need to protect our planet's ecosystems. Collins ardently hoped that political leaders and decision-makers would one day embrace the cosmic perspective he had gained, one that sees Earth not just as a resource, but as a precious, interconnected home, worthy of care and respect. The solitude of space became a crucible for profound introspection. It compelled Collins to confront existential questions that reshaped his beliefs and spiritual outlook. Before his journey, he was not overtly religious. However, the cosmic voyage awakened in him a deep sense of purpose and order within the universe. A spiritual awakening born from the quiet vastness of space. For nearly a day, Collins was the loneliest human alive, orbiting the far side of the moon in complete radio silence. Yet rather than feeling isolated or fearful, he cherished this solitude. The silence became a sanctuary where he could meditate on life's most profound questions. Who are we? What is our role in the cosmos? How can we protect our planet from looming peril? These contemplations, born in the serene expanse of space, infused Collins with a heightened sense of environmental responsibility. His journey was not just a physical voyage beyond Earth's bounds, but a transformative experience that deepened his commitment to preserving the planet for future generations. Through his unique vantage point, Collins emerged not only as an explorer of space, but as a guardian of Earth's fragile legacy. Michael Collins' solitary orbit around the moon's far side transformed him into a thoughtful steward of Earth. This unique experience deepened his advocacy for unity, highlighting the profound interconnectedness of all life on our planet. Though often called the quiet astronaut, Collins became much more than a pilot. He emerged as a philosopher, an astronaut who contemplated the universe's deepest mysteries while circling our celestial neighbor. The Apollo 11 mission was not only a giant leap for mankind, it was also a voyage of self-discovery and cosmic perspective. From the lunar far side, Michael Collins gazed upon Earth with a clarity and reverence that few have ever known. His vision invites us all to reflect on our place within the vast universe and to cherish and protect our fragile planet, our only cradle of life amidst the cosmic void. Collins's legacy extends far beyond the boundaries of the lunar module. He inspires us to explore the limitless realms of space, while at the same time safeguarding the sanctity of our home, Earth. His story is a timeless reminder of humanity's indomitable spirit, boundless curiosity, and the responsibility that comes with our unique vantage point in the cosmos. As we continue our journey ever deeper into the vast expanse of the cosmos, we carry with us the enduring wisdom and profound insights of Michael Collins, the astronaut who found tranquility, enlightenment, and a unique sense of purpose in the solitude of space. His experience orbiting silently around the far side of the moon, away from the voices of Earth and the company of his fellow explorers, was not one of loneliness, but of deep reflection. In that serene isolation, Collins discovered a powerful reminder of the fragile beauty and interconnectedness of all life on our home planet. His perspective transcends the boundaries of space travel. It speaks to the very core of the human spirit, the relentless drive to explore, to understand, and to connect. Collins's journey is a testament to the enduring nature of human curiosity and the capacity for awe when confronted with the infinite mysteries of the universe. It reminds us that no matter how far we venture into the stars, our roots remain tied to Earth, a delicate and precious oasis in the cosmic wilderness. In embracing Collins's legacy, we are called not only to push the frontiers of science and exploration, but also to nurture and protect the fragile ecosystems of our planet. His story encourages us to cultivate a global consciousness, one that honors the delicate balance of life and acknowledges the shared responsibility we bear for its preservation. As humanity steps boldly forward into new chapters of cosmic discovery, may we do so with the same spirit of humility, unity, and reverence that Michael Collins exemplified. His voyage teaches us that true exploration is not merely about reaching new worlds, but about gaining deeper insight into our own, fostering wisdom, compassion, and an unwavering commitment to the interconnected web of life that sustains us all. In the cold expanse of space, more than 3.7 billion miles from Earth, a silent witness of human ingenuity floated on, a tiny spacecraft known as Voyager 1. Launched in 1977, its mission was clear: journey past the gas giants Jupiter and Saturn and send back data no human had ever seen before. But what no one could have predicted was how this uncrewed emissary of Earth would go on to redefine our place in the universe. As Voyager neared the end of its primary mission, astronomer Carl Sagan proposed something revolutionary. He convinced NASA to command Voyager to turn its camera around, not toward the vast cosmos ahead, but back toward home. The request was simple in action, but profound in meaning. It was a cosmic glance backward. On February 14, 1990, Voyager 1 snapped a photograph that would echo through history. Amidst the deep black of space, Earth appeared as a tiny speck, less than a pixel in size, bathed in a scattered ray of sunlight. This now famous image was dubbed the pale blue dot. In that image, suspended in a sunbeam, lay all of human history. Every person, every story, every dream, and every conflict. Earth, our only known haven, reduced to a microscopic fleck against the backdrop of infinity. Carl Sagan would later reflect, "Look again at that dot. That's here. That's home. That's us. The Earth is a very small stage in a vast cosmic arena." Voyager 1's journey didn't end there. Long after it completed its planetary tour, the spacecraft entered the realm of interstellar space, becoming the first human-made object to cross the heliopause, the boundary where the sun's influence ends and the interstellar medium begins. It continues to transmit data, whispering tales of the void, back to Earth across nearly 15 billion miles. What began as a mission to study planets has evolved into a voyage that challenges our understanding of space, time, and what it means to be human. The pale blue dot image remains not just a photograph, but a mirror. It reflects our fragility, our unity, and the staggering responsibility we have to care for this mote of dust suspended in a sunbeam. Voyager 1 and the 500 mysterious objects, a new cosmic enigma. Voyager 1, a name that echoes through the corridors of astronomical history, stands as one of humanity's greatest achievements. Launched in 1977, this spacecraft was designed to explore the outer planets, but over the decades it has evolved into something far more profound, a symbol of our relentless curiosity and an ambassador of Earth to the cosmos. Against all odds, Voyager 1 continues to operate, more than 47 years after its launch, at a staggering distance of nearly 15 billion miles from Earth. Its instruments, though aged, still whisper back to us across the vast emptiness of space. Every signal it sends is a triumph of engineering and a reminder of humanity's reach into the stars. Throughout its journey, Voyager 1 has pushed the boundaries of what we once believed possible. It has not only revealed the secrets of distant planets like Jupiter and Saturn, but also reshaped our understanding of the interstellar medium, that faint, invisible ocean of plasma and radiation between the stars. But now, a new mystery has emerged, one that has gripped the attention of the scientific world. Recently, Voyager 1's instruments made a stunning and unexpected detection. 500 unknown objects silently drifting through the cosmic abyss. These objects, each traveling independently, appeared suddenly on the spacecraft sensors, an anomaly that has left scientists both thrilled and perplexed. What are these mysterious travelers? Are they fragments of ancient celestial bodies? Are they particles from an interstellar storm? Or could they be something even more extraordinary? Phenomena never before observed by humankind? The discovery has triggered a wave of research and speculation. Teams of astrophysicists around the globe are now analyzing the data, trying to decode the origin and nature of these cosmic phantoms. What makes this even more compelling is the environment in which these objects were detected. Deep within the interstellar void, far beyond the influence of our sun. This region is colder, darker, and more mysterious than any Voyager has ever encountered. It is a place where gravity is weak, light is scarce, and time seems to slow. Some experts suggest that the objects could be dust particles or icy fragments drifting from an ancient, distant collision. Others believe they might be remnants of interstellar comets, or even signatures of unknown forces at work in the vast architecture of space. Yet a few daring voices in the scientific community have raised a more controversial question. Could these 500 objects be artificial in nature? While there is no concrete evidence to support this idea, the mere possibility is enough to reignite age-old questions about life beyond Earth and whether we are truly alone in the cosmos. For now, the mystery remains. Voyager 1, ever silent, continues on its eternal voyage, a lone sentinel carrying the hopes and questions of humanity. As we await further analysis, this discovery reminds us of a powerful truth. The universe is far stranger, more complex, and more beautiful than we can yet comprehend. With every signal Voyager sends back to Earth, it extends the horizon of human to wonder what lies beyond. So, stay tuned as we continue to follow this unprecedented chapter in the Voyager legacy. For in the endless black of space, new secrets are always waiting to be uncovered. And sometimes, the most astonishing stories are written not in ink, but in stardust. Voyager 1's enduring mystery and the Tyson revelation. The revelation of the 500 mysterious objects detected by Voyager 1 has sent ripples through the scientific community. But the intrigue reached an entirely new level when it caught the attention of one of the world's most recognizable voices in astrophysics, Neil deGrasse Tyson. Known for his ability to translate cosmic wonders into captivating insights, Tyson has publicly acknowledged this finding as a landmark moment in the narrative of space exploration. These unidentified entities challenge our long-held assumptions about what exists in the remote expanses of interstellar space. They represent a new class of phenomena, not fitting neatly into the categories that scientists have spent decades constructing. Are they natural? Are they the remnants of an ancient event? Or are we seeing something never before imagined? Yet, beyond the mystery of the objects themselves lies another astonishing truth. Voyager 1 is still functioning. Launched nearly half a century ago, the spacecraft continues to relay data across billions of miles. This resilience is not just remarkable, it's unprecedented. In an age where modern electronics are designed with obsolescence in mind, Voyager 1 stands as a monument to engineering brilliance and robust foresight. One of the key reasons for this longevity lies in its onboard architecture. Voyager was equipped with redundancy, a survival trait often overlooked in today's fast-evolving technology landscape. It possesses dual-command computer subsystems, including the Fly Data Subsystem, FDS, responsible for processing and formatting scientific and engineering data. The Attitude and Articulation Control Subsystem, AACS, managing orientation, stabilization, and communications alignment with Earth. This duplication of systems enables automatic failovers, meaning if one system degrades, another can be activated, even after years of dormancy. This strategy has been crucial in preserving the spacecraft's operational integrity, especially as it endures the harsh conditions of interstellar space. Despite the age of its 1,970 Sera circuitry, Voyager 1 continues to defy the odds. Its systems, though primitive by modern standards, are incredibly durable. Each signal it sends is a triumph over time, distance, and entropy itself. As we contemplate the implications of this new discovery, we are reminded of the enduring legacy of Voyager. It is not only revealing the mysteries of the cosmos, but also highlighting the limitless potential of human ingenuity. In a universe defined by change and uncertainty, Voyager is a constant, a silent traveler speaking across time, urging us to keep asking, keep seeking, and never stop wondering. Power, precision, and the lifeline of the cosmos. In the harsh and unforgiving expanse of interstellar space, power management is not just important, it is pivotal to the survival of Voyager 1. With a finite and steadily dwindling onboard energy source, every watt counts. As the spacecraft journeys farther from the Sun and deeper into the abyss, preserving power has become an intricate balancing act. To sustain operations, NASA's engineers have employed a series of ingenious strategies. Through a process known as selective power reduction, non-essential components and subsystems, those not critical to the mission's core scientific functions, are systematically deactivated. These are tough decisions. Every system switched off means less capability, fewer instruments, and sometimes lost opportunities. But it's a necessary compromise in the pursuit of longevity. This strategic conservation is guided by one core principle: maximize science with minimal power. The spacecraft's remaining instruments are carefully prioritized, ensuring that it can continue transmitting priceless data from regions of space never before explored by humankind. But even with functioning systems, Voyager 1 is only half the story. To receive its signals, faint whispers from a spacecraft now nearly 15 billion miles away, we rely on an equally remarkable Earth-based counterpart, NASA's Deep Space Network. The Deep Space Network is humanity's cosmic lifeline, a vast communication infrastructure that allows us to stay connected with spacecraft, journeying across our solar system and beyond. This high-tech web consists of massive radio antennas strategically positioned around the globe, including Goldstone, nestled in the arid expanse of California's Mojave Desert, Madrid, Spain, and Canberra, Australia. This triad ensures that no matter Earth's rotation or Voyager's position in space, at least one station is always within reach to listen for the spacecraft signal and to transmit instructions. These towering antennas, some measuring up to 70 meters in diameter, are marvels of engineering in their own right. They're capable of detecting signals that arrive with less power than a billionth of a watt, equivalent to the energy of a falling snowflake. And yet, with incredible precision, they continue to capture data from the edges of interstellar space. As Voyager 1 continues its journey, each byte of data it sends is the result of a delicate interplay between onboard power efficiency and Earth-based technological excellence. It is a story of resilience, adaptation, and relentless pursuit. A story powered by innovation and connected by a global network that refuses to let our greatest traveler be forgotten in the void. Signals across the stars, communication and cosmic mysteries. To ensure uninterrupted communication with spacecraft like Voyager 1, even as Earth spins on its axis, NASA's Deep Space Network, DSN, relies on a triad of global facilities. These include Madrid in the heart of Spain, Canberra in the vast landscapes of Australia, and Goldstone in California's Mojave Desert. Together, these sites form a global listening post, maintaining round-the-clock coverage of our deep space emissaries. At the core of each DSN site stand colossal radio antennas, towering marvels engineered to capture the faintest whispers from the cosmos. These massive dishes are the literal ears through which humanity listens to the universe. Through them, radio waves carrying precious scientific data travel between Earth and spacecraft across billions of miles. Though these transmissions move at the speed of light, the immense distance between Earth and Voyager 1 introduces a unique challenge: a 22-hour delay for signals to reach the spacecraft and another 22 hours for a reply to return. In total, every exchange takes nearly 2 full Earth days. This significant delay demands meticulous planning and precise execution from mission control. Every command must be perfectly calculated, tested, and transmitted with zero margin for error. A testament to the skill and patience of the teams guiding this interstellar mission. And just when we thought Voyager 1's journey had settled into predictable patterns, it presented the scientific community with an astonishing discovery. 500 mysterious, unidentified objects traversing the cosmic void. These enigmatic entities, never before encountered or catalogued, have captured the imagination of both scientists and the public. What are they? Natural phenomena? Cosmic anomalies? Or something else entirely? One thing is certain: these objects have reignited the spirit of curiosity and wonder that launched Voyager 1 in the first place. As we peer deeper into the unknown, the cosmos continues to surprise us, reminding us that the final frontier still holds secrets we have only begun to uncover. Voyager 1, enduring spirit in the cold silence of space. One could argue that these unexpected discoveries are not just anomalies. They are a testament to Voyager 1's extraordinary legacy, a mission that has far surpassed its original scope. Each new revelation serves as a reminder of humanity's unyielding curiosity. The same force that dared to send a small probe into the abyss, chasing questions bigger than ourselves. Voyager 1 continues its journey billions of miles from the Sun, where solar energy becomes increasingly scarce. To adapt to this harsh environment, NASA engineers have developed sophisticated power management strategies. These aren't just about conserving energy, they are about evolving with the mission. In addition to carefully turning off non-essential systems, a process known as selective power reduction, engineers have implemented adaptive techniques that dynamically respond to Voyager's environment. These strategies prioritize critical instruments and communications, ensuring that even as the spacecraft's power supply dwindles, it can still beam back data from the cosmic frontier. Over the decades, there have also been technological refinements in how Voyager's limited energy is distributed. Improvements in power flow, more efficient circuit routing, and even reprogramming from billions of miles away have allowed NASA to extend the mission's lifespan far beyond expectations. Even the spacecraft's aging batteries, now operating under conditions never anticipated during their design, have outperformed all projections. Through a combination of foresight, adaptability, and sheer ingenuity have kept Voyager 1 alive, a beacon in the dark, still whispering secrets from the stars. Voyager's lifeline: power, precision, and the deep space network. Thanks to continual advancements in charging systems, power regulation, and control mechanisms, Voyager 1 remains a marvel of endurance. Engineers have spent decades fine-tuning every watt, every surge, every current, stretching the lifespan of systems once never meant to last more than a decade. Through these innovations, Voyager 1's epic scientific odyssey continues across the silent, infinite reaches of space. But power alone isn't enough. To make sense of the data Voyager collects, to hear its distant voice, we rely on a remarkable network here on Earth, NASA's Deep Space Network, or DSN. This colossal system of global antennas is humanity's ear to the cosmos, a technological marvel that connects us to spacecraft hurtling through deep space billions of miles away. Strategically positioned across the globe in Goldstone, USA, Madrid, Spain, and Canberra, Australia, the DSN ensures that as Earth rotates, at least one massive antenna is always in range to catch Voyager's faint signal. These radio waves traveling at the speed of light still take over 22 hours to reach us. That means any command sent and any data received must be planned with incredible precision and patience. Through this carefully orchestrated dance of power management and interstellar communication, Voyager 1 continues to do what no other spacecraft has ever done: explore the great unknown and send home whispers from the edge of forever. However, the role of the Deep Space Network, DSN, extends far beyond simply transmitting data. It also functions as a powerful platform for conducting radar and radio astronomy observations, allowing scientists to peer deeper into the cosmos and unravel some of the universe's most profound mysteries. What truly sets the DSN apart is its spirit of global collaboration. It works hand in hand with other space agencies and their networks, including the Soviet, Chinese, Indian, and Japanese deep space networks, as well as the European Space Agency's tracking facilities. This international cooperation forms a united front in humanity's collective quest to explore and understand the wonders of space. The DSN itself is composed of three main communication facilities: each strategically positioned about 120 degrees apart around the globe. These sites are located in Goldstone, California, Madrid, Spain, and Canberra, Australia. This global arrangement ensures continuous communication with distant spacecraft as the Earth rotates, maintaining an unbroken connection to the farthest reaches of our solar system and beyond. Located in California's Mojave Desert, Madrid, Spain, and Canberra, Australia, this strategic geographical arrangement ensures uninterrupted coverage and communication with spacecraft, even as our planet continuously rotates. Because of this global network, the Deep Space Network, DSN, stands as the world's most expansive and advanced scientific telecommunication system. At the heart of the DSN's communication capability are its colossal radio antennas, stationed at each facility. These towering antennas act as vital conduits, enabling radio waves to travel vast distances between Earth and distant spacecraft. When data is transmitted from a spacecraft back to Earth, the DSN often uses Channel 18, which operates on frequencies of either 2.3 GHz or 8.4 GHz, ensuring clear and reliable communication across billions of miles. Conversely, when sending signals from Earth to Voyager 1, a frequency of 2.1 GHz is used. Despite the incredible speed of radio waves, it still takes approximately 22 hours for a signal to reach Voyager 1. This significant time delay presents unique challenges for mission control teams, requiring meticulous planning and precise execution of commands. Any errors or unexpected issues can lead to further delays and complications, especially during the investigation of anomalies like those Voyager 1 occasionally encounters. Moreover, this communication lag limits real-time control and interaction with the spacecraft. Unlike missions closer to Earth within our solar system, where time delays are minimal, the vast interstellar distances introduce substantial communication delays. As a result, instantaneous conversations or quick adjustments based on real-time observations are simply impractical. Yet, despite these challenges, the Deep Space Network stands as a shining example of human achievement in space exploration. It is a testament to our capacity to overcome vast cosmic distances and gradually unravel the universe's secrets, one data transmission at a time. Resolving this particular anomaly required a meticulous process of troubleshooting and corrective action. After extensive efforts and numerous back-and-forth communications with Voyager 1, mission teams finally identified the source of the problem. The issue was traced to the spacecraft's command and control subsystems, which are responsible for receiving and executing instructions sent from Earth. Further investigation revealed that an unexpected electrical surge had occurred within these subsystems, disrupting normal operations. This electrical surge triggered a cascade of unintended actions within Voyager 1's onboard computer systems. As a result, the spacecraft generated and transmitted a peculiar message back to Earth, one that initially baffled mission teams. The surge had temporarily disrupted normal operations, causing a chain reaction of events that culminated in this intriguing and unexpected situation. In response, engineers and mission controllers at NASA's Jet Propulsion Laboratory sprang into action, working tirelessly around the clock to diagnose and resolve the anomaly. Their approach involved developing a carefully coordinated plan to reset and restart the affected command and control subsystems. This procedure was delicate and required precise timing and coordination to ensure that the spacecraft's vital systems could safely return to their normal, stable state without risking further complications. The successful resolution of this anomaly stands as a powerful testament to the incredible expertise, dedication, and problem-solving skills of the teams managing Voyager 1's mission. Their ability to troubleshoot and correct such a complex issue at an unimaginable distance, nearly 15 billion miles from Earth, demonstrates the remarkable human ingenuity behind deep space exploration. Moreover, this episode highlights the formidable challenges inherent in venturing beyond our solar system. In the harsh and unforgiving environment of interstellar space, unexpected events like electrical surges or system malfunctions can arise without warning, often due to extreme cosmic radiation, temperature fluctuations, and the sheer isolation of the spacecraft. Such conditions test not only the resilience of the spacecraft itself, but also the ingenuity and resolve of the engineers and scientists tasked with its care. As Voyager 1 continues its relentless journey through the cosmic abyss, this incident serves as a poignant reminder of both the fragility and resilience of human technology when pushed to its limits. Despite decades of travel and numerous obstacles, Voyager 1 remains an enduring symbol of human curiosity, perseverance, and the relentless pursuit of knowledge about the universe beyond our small blue planet. As Voyager 1 continues its epic journey through interstellar space, it stands as a powerful symbol of humanity's enduring spirit of exploration and discovery. Launched in 1977, this spacecraft has far surpassed all initial expectations, consistently delivering groundbreaking insights into the cosmos. Despite facing numerous challenges throughout its decades-long mission, including the recent anomaly, it remains a shining testament to human ingenuity and our relentless quest to unravel the mysteries of the universe. Voyager 1 has defied all odds, operating well beyond its original designed lifespan. Its remarkable longevity reflects the skill, dedication, and foresight of the engineers and scientists who crafted the spacecraft and continue to oversee its mission. Since its launch on September 5, 1977, Voyager 1's primary objective was to study the outer planets of our solar system, but its legacy has expanded far beyond this initial goal. Voyager 1's original mission focused on exploring the outer planets of our solar system, including the magnificent gas giants Jupiter and Saturn. Launched in 1977, the spacecraft embarked on an ambitious journey to study these distant worlds up close. Its encounters with Jupiter in 1979 and Saturn in 1980 stand as some of the most significant milestones in the history of space exploration. During these flybys, Voyager 1 transmitted to Earth an unprecedented wealth of images and scientific data that transformed our understanding of these massive planets and their complex systems. Voyager 1's discoveries were nothing short of revolutionary. It uncovered previously unknown moons orbiting Jupiter and Saturn, revealing that these planets were accompanied by rich, dynamic satellite families. The spacecraft also captured detailed views of intricate ring systems encircling both planets, structures that were far more complex and varied than scientists had ever imagined. These insights reshaped planetary science, deepening our knowledge of the formation, composition, and behavior of giant planets and their environments. Following its successful planetary encounters, Voyager 1 continued its voyage outward, eventually crossing the boundary of our solar system and entering interstellar space, the vast, largely uncharted region between the stars. This achievement marked a historic first. Voyager 1 became the very first human-made object to venture into interstellar space, a testament to human curiosity and technological ingenuity. Its instruments continue to send back valuable data about the properties of this mysterious region, including the interstellar medium's magnetic fields, cosmic rays, and plasma waves. One of Voyager 1's most enduring legacies came in 1990, when the spacecraft captured one of the most iconic images in the history of astronomy, the famous pale blue dot. At the request of astronomer Carl Sagan, Voyager 1 turned its cameras back toward Earth and took a photograph from an extraordinary distance of about 3.7 billion miles. In this image, Earth appears as a tiny, fragile speck suspended in a sunbeam, barely visible against the vastness of space. The pale blue dot serves as a humbling and powerful symbol of the fragility and uniqueness of our home planet. It reminds us of the singular place we occupy in the cosmic vastness, urging humanity to cherish and protect our delicate world. This poignant perspective, captured by Voyager 1, continues to inspire reflection on our place in the universe and the shared responsibility we have toward Earth and its future. Voyager 1's extraordinary journey through the solar system and beyond has yielded invaluable insights, not only about distant planets, but also about the very nature of our Sun and its expansive influence. Throughout its mission, Voyager 1 has been a vigilant observer of the solar wind, a continuous stream of charged particles emitted by the Sun, and the heliosphere, the vast, bubble-like region of space dominated by the Sun's magnetic field and solar wind. One of the most remarkable milestones in Voyager 1's mission came in 2012, when it crossed the heliopause, the boundary where the solar wind slows down and meets the interstellar medium. This crossing marked Voyager 1's historic entry into interstellar space, a realm far beyond the reach of our Sun's direct influence. Since then, Voyager 1 has been providing the scientific community with invaluable data about the conditions that exist in this cosmic frontier. Its instruments measure the density, temperature, and magnetic properties of interstellar plasma, giving us our first close-up glimpse of the space between stars. Perhaps one of the most astonishing aspects of Voyager 1's ongoing mission is its ability to maintain communication with Earth despite the staggering distance, over 14.5 billion miles away. This communication is made possible through NASA's Deep Space Network, DSN, a global array of massive radio antennas that act as a vital bridge between the spacecraft and mission control on Earth. The signals Voyager 1 sends travel at the speed of light, but still require more than 21 hours to reach us. This time delay underscores the immense challenges and scale involved in deep space exploration, where even light takes nearly a full day to traverse the vast gulf between Earth and the spacecraft. Recently, Voyager 1 experienced an intriguing anomaly that captured the imagination of scientists and the public alike. The spacecraft transmitted a mysterious and unexpected message, leading to widespread speculation and curiosity. While some entertained the idea that this might be an intentional communication attempt or a cryptic signal from the far reaches of space, the truth is more grounded in the complexities of operating a spacecraft far beyond its intended lifespan. NASA's engineers and mission controllers promptly sprang into action to investigate the cause of this anomaly. Through meticulous troubleshooting and careful analysis, they determined that the unusual message was the result of a temporary electrical surge in Voyager 1's command and control systems. This surge caused a brief disruption in the spacecraft's normal functioning, leading to the transmission of the unexpected signal. The dedicated teams at NASA's Jet Propulsion Laboratory worked tirelessly to reset and restore Voyager 1's systems, ensuring the spacecraft continued its invaluable scientific mission. This incident serves as a powerful reminder of the immense technical challenges involved in deep space missions. Voyager 1, now more than 4 decades old, operates in the harsh environment of interstellar space where cosmic radiation, extreme temperatures, and the vast distances from Earth continually test its resilience. Yet, it remains a symbol of human ingenuity, perseverance, and our insatiable desire to explore the unknown. Voyager 1's journey is far from over. As it continues to sail through the interstellar medium, it carries with it humanity's hopes, curiosity, and legacy, transmitting data that deepens our understanding of the cosmos and inspiring generations to look up and wonder about the universe beyond our small blue planet. The recent anomaly, transmitted by Voyager 1, sparked widespread speculation and fascination. Some entertained the thrilling possibility that the mysterious signal could be a form of communication from an advanced extraterrestrial civilization, an unprecedented breakthrough in humanity's search for cosmic neighbors. While such a scenario captivates the imagination, the most plausible explanation, grounded in technical reality, was an electrical surge within Voyager 1's command and control systems. This surge temporarily disrupted the spacecraft's normal operations, causing it to send an unexpected and peculiar message back to Earth. This incident brought to light the immense challenges and complexities involved in managing and operating a spacecraft on such an extraordinary interstellar journey. Voyager 1, launched over 4 decades ago, was never originally designed to travel this far or last this long, yet it continues to function in one of the most hostile environments imaginable. The spacecraft's aging electronics, exposure to intense cosmic radiation, and the sheer distance from Earth all combine to create a uniquely difficult operating environment that demands constant vigilance and expert care from the dedicated mission teams. In conclusion, Voyager 1 stands as a towering symbol of human achievement and the enduring spirit of exploration. Its mission, which began with the goal of studying the outer planets of our solar system, has transcended all expectations to become an unprecedented voyage into the interstellar unknown. Through its incredible longevity and resilience, Voyager 1 has delivered an extraordinary wealth of scientific knowledge, profoundly expanding our understanding of the solar system and the vast universe beyond. More than just a scientific instrument, Voyager 1 is a testament to the ingenuity, dedication, and relentless curiosity of the engineers, scientists, and visionaries who have guided its journey over the decades. As it ventures deeper into interstellar space, Voyager 1 reminds us that the boundaries of human exploration are limited only by our imagination and determination. It embodies the boundless possibilities that lie beyond the familiar confines of our solar system, and serves as a beacon, inspiring future generations to pursue the mysteries that await us in the cosmos. Voyager 1's Odyssey invites us to reflect on our place in the universe, a tiny speck suspended in the vast cosmic sea, and challenges us to continue reaching outward, seeking answers to the profound questions about existence, life, and the nature of the universe itself. The spacecraft's ongoing mission will remain a symbol of hope and discovery for years to come, a shining example of humanity's enduring quest to explore the final frontier. Beneath the rolling green hills and quiet villages of the Swiss countryside lies one of the most sophisticated and powerful scientific instruments ever created by humankind, the Large Hadron Collider, LHC. This sprawling underground facility, stretching across the border between Switzerland and France, represents humanity's most ambitious effort to unlock the secrets of the universe. Built and operated by CERN, the European Organization for Nuclear Research, the LHC is a technological marvel, designed to probe the deepest layers of physical reality. For over a decade, the LHC has been pushing the boundaries of scientific understanding by accelerating subatomic particles to near-light speeds and smashing them together in high-energy collisions. It has given scientists glimpses into the conditions that existed just moments after the Big Bang. In 2012, the LHC made headlines worldwide when it confirmed the existence of the Higgs boson, also known as the God particle, a discovery that earned a Nobel Prize and completed the standard model of particle physics. But now, something unexpected has emerged. Recent experiments conducted deep within the collider's tunnels have revealed anomalies so profound and puzzling that they are challenging the very foundations of modern physics. These strange phenomena have sparked a storm of speculation and concern among leading physicists, with some whispering that CERN may have uncovered something far more powerful and potentially dangerous than they ever intended. Rumors of inexplicable data patterns, unusual energy signatures, and even the possible detection of particles that don't belong in our known universe have started to circulate. As researchers scramble to verify the results, one question is becoming increasingly urgent. What has the Large Hadron Collider really discovered? And are we ready for the truth? Why are scientists like Michio Kaku alarmed by CERN's latest experiments? In recent months, whispers of extraordinary discoveries and unsettling possibilities have echoed through the corridors of the global scientific community. Among those raising eyebrows is none other than Dr. Michio Kaku, the world-renowned theoretical physicist and futurist. Known for his ability to translate complex scientific ideas into understandable insights for the public, Dr. Kaku has never shied away from bold questions about the future of humanity, but even he now appears visibly concerned about the latest developments at CERN. So, what exactly is happening beneath the Alps? What revelations have emerged from the Large Hadron Collider that could possibly prompt speculation about doomsday scenarios? The stakes are nothing short of astronomical. The LHC, often called the atom smasher, has always straddled the line between brilliance and danger. Capable of accelerating particles to 99.999999% the speed of light and smashing them together with energies never before produced on Earth, the collider mimics conditions not seen since the birth of the universe itself. These monumental collisions have allowed scientists to peer into the subatomic world, discovering particles, forces, and phenomena previously confined to theory. Before its launch, some experts and skeptics worried aloud, what if we accidentally created a black hole? What if we opened a portal to another dimension? Could we unleash energies that Earth was never meant to experience? Those concerns were largely dismissed as science fiction, until now. New data emerging from LHC experiments suggests the detection of highly anomalous energy patterns, behaviors that defy the current laws of particle physics. These readings have baffled scientists and prompted intense scrutiny. While CERN maintains a tone of calm curiosity, others, including Michio Kaku, are calling for caution. According to Kaku, we are possibly stepping into a new chapter of physics, one that may unravel not just scientific understanding, but even the fabric of reality as we know it. Is it simply an incredible leap forward for science? Or have we crossed a threshold into something we cannot fully control? As speculation mounts and public concern grows, many are asking, should the LHC be shut down? Are we toying with forces beyond comprehension? The truth, as we'll uncover in the next part of this story, is as fascinating as it is unsettling. The return of the LHC, and a disturbing new chapter. For decades, humanity's understanding of the universe teetered on the edge of the unknown. The very laws that govern our existence, gravity, quantum mechanics, time and space, formed only a partial portrait of a vast and intricate cosmic tapestry. Many of the most profound mysteries, such as the nature of dark matter, the origins of mass, and the fundamental structure of reality, remained cloaked behind an impenetrable veil. And scientists could theorize and speculate, but they lacked the tools to test these ideas in the crucible of real-world data. That all changed with the birth of the Large Hadron Collider, LHC-PHA machine, so powerful, so precise, that it could recreate conditions just moments after the Big Bang. Situated deep beneath the peaceful Swiss-French border at CERN, the European Organization for Nuclear Research, the LHC became more than just a scientific instrument. It became a doorway. One capable of peering into realms of existence we once thought were forever hidden. The Collider made history in 2012 with the discovery of the Higgs boson, a particle long theorized but never before observed. This breakthrough not only earned a Nobel Prize, but also validated the standard model of particle physics, the framework used to understand how the universe behaves at its most fundamental level. But for all its triumphs, the LHC went quiet into 2019, entering a planned 3-year hiatus for upgrades. Then, in April 2022, the machine roared back to life. This marked the beginning of Run 3, a new era of high-energy experimentation that would continue until 2024. With enhanced detectors, increased beam energy, and upgraded computational capabilities, the LHC was now more powerful than ever before. Scientists around the world eagerly anticipated a flood of new discoveries, many of which were expected to challenge the boundaries of known physics. But amidst the excitement, a chilling announcement from CERN began to circulate. In a statement that surprised even seasoned researchers, CERN hinted at unexpected results that do not align with established models. Though vague in language, the tone of the communication sparked immediate speculation. Had the LHC found evidence of a new force of nature, or something even more exotic, such as extra dimensions, unknown particles, or destabilizing phenomena? Whispers of abnormalities in particle decay rates, anomalies in high-energy collisions, and energy distributions that seemingly violated conservation laws started to spread. What once felt like a methodical, controlled exploration of subatomic particles had suddenly become a foray into uncharted territory. Renowned physicists like Dr. Michio Kaku began to speak out, not out of fear-mongering, but concern. In his view, humanity may be on the verge of breaking through the ceiling of known physics, stepping into a domain where our current understanding no longer applies, and where the consequences could be unpredictable. As the scientific community holds its breath, CERN's vague statement continues to ripple across media channels and theoretical forums alike. What could be so profound and so potentially dangerous that even the world's most confident researchers are beginning to question the course of these experiments? In the next chapter of this story, we'll dive deeper into the possibilities, from miniature black holes to parallel universes, and the deeply unsettling idea that reality itself may not be as stable as we once believed. The heart of human curiosity. Activating the Large Hadron Collider, In one of the most ambitious scientific endeavors in human history, the Large Hadron Collider, LHC, was brought to life through a monumental collaboration involving over 10,000 scientists and hundreds of universities and laboratories spread across the globe. This international partnership, led by the European Organization for Nuclear Research, CASRRN, set out to construct a machine that could answer the most profound questions ever asked about our universe. Between 1998 and 2008, the LHC took shape, an engineering masterpiece hidden deep beneath the tranquil countryside near Geneva, straddling the border between France and Switzerland. At the core of this marvel is a 27-kilometer, 17-mile circular tunnel, buried approximately 175 meters underground, where conditions rival the earliest moments of the universe itself. In 2010, history was made. The LHC achieved its first particle collision at an energy level of 3.5 tera electron volts per beam, nearly 4 times greater than any previous collider on Earth. The record-breaking event marked a turning point in particle physics. It was a bold step into the unknown, and the world held its breath. But CERN didn't stop there. Through a series of advanced upgrades and enhancements, the collider's power grew exponentially. Today, the LHC can accelerate particles to an astonishing 6.5 TeV per beam, enabling experiments that were once thought to be the stuff of science fiction. At the core of the LHC's scientific capabilities lie 4 primary collision points, precise locations within the ring where 2 beams of particles are made to collide head-on at nearly the speed of light. Around these collision points are stationed 7 sophisticated detectors, each meticulously designed to observe and analyze specific types of particle interactions. Each detector tells a different part of the story. From Atlas, the largest detector tasked with studying everything from dark matter to extra dimensions, to CMS, which helped confirm the existence of the Higgs boson. These instruments act as the eyes and ears of the collider, capturing fleeting subatomic phenomena that exist for just fractions of a second. Together, these detectors and collision points form the neural network of the LHC, enabling us to delve deeper into the very fabric of reality. But as the collider's power continues to increase, so do the stakes. Every collision has the potential to uncover phenomena that challenge the fundamental assumptions of physics. With the LHC now entering its most ambitious phase yet, scientists are beginning to observe strange anomalies and unexplained behaviors, sparking both excitement and caution among the world's leading physicists. What lies ahead? What forces, particles, or even dimensions might the LHC unlock next? Stay with us as we continue exploring the enigmatic breakthroughs, unanswered questions, and possible dangers that are now emerging from the world's most powerful machine, beyond protons, unlocking deeper secrets with the LHC. While the Large Hadron Collider, LHC, is primarily renowned for its proton-proton collisions, its capabilities extend far beyond smashing just those subatomic particles. In a feat of engineering versatility, the LHC is also equipped to accelerate heavy ion beams, such as those composed of lead nuclei, opening new avenues of exploring the most extreme states of matter in the universe. Each year, CERN dedicates approximately 1 month to conducting heavy ion collisions, allowing scientists to recreate conditions similar to those just microseconds after the Big Bang. During the rest of the year, the focus returns to high-energy proton-proton experiments, which continue to be the cornerstone of the collider's mission. At its core, The fundamental goal of the LHC is to test and validate the predictions of particle physics theories, particularly those described by the Standard Model, a theoretical framework that outlines the fundamental particles and the forces that govern their behavior. The LHC is also a key instrument in investigating new physics beyond the Standard Model, such as the elusive world of supersymmetry, which proposes the existence of an entire hidden realm of partner. A major highlight in the LHC's journey came in 2012, when it famously confirmed the existence of the Higgs boson, the long-sought particle that gives mass to everything in the universe. Since then, physicists have used the collider to probe the Higgs boson's properties, hoping to uncover signs of deeper layers of reality still hidden beneath the surface. But what exactly is a hadron, and why does it matter? The term hadron refers to composite subatomic particles made up of smaller constituents called quarks, which are held tightly together by the strong nuclear force, the most powerful of the four known fundamental forces in nature. This force is analogous to how electromagnetism binds atoms into molecules, but on a much smaller and more powerful scale. There are two main types of hadrons: baryons, such as protons and neutrons, which make up the nuclei of atoms; mesons, like the pion and kaon, which are often produced in high-energy interactions, and were first discovered in cosmic ray experiments during the late 1940s and early 1950s. To study hadrons and their interactions, physicists need extremely high-energy environments, far beyond what can be achieved naturally on Earth. That's where colliders come into play. A collider is a highly specialized type of particle accelerator that pushes beams of particles in opposite directions at nearly the speed of light, eventually slamming them into each other to create tiny fireballs of raw energy. These collisions produce a flurry of particles, often for mere billionths of a second, allowing scientists to observe processes that haven't occurred naturally since the dawn of the universe. Though building and operating these massive machines is immensely challenging and expensive, their scientific payoff is priceless. Unlike fixed target experiments, where particles are fired at stationary material, colliders can achieve much higher center of mass energies, vastly increasing the probability of generating rare or never-before-seen particles. In essence, colliders like the LHC function as cosmic microscopes, peering into the very building blocks of existence, recreating conditions from the early universe and enabling breakthroughs that redefine our understanding of the cosmos. Peering into the quantum abyss, the anatomy and design of the LHC. What makes the Large Hadron Collider such a powerful window into the fabric of the universe isn't just its immense energy, but its ability to produce rare and fleeting subatomic byproducts, particles so short-lived that they exist for less than a fraction of a second before vanishing. These byproducts, created in high-energy collisions, are the only clues scientists have to explore realms that otherwise remain inaccessible. Many of these particles do not occur naturally on Earth anymore. They can only be reproduced in extremely energetic environments, just like those that existed in the moments following the Big Bang. By studying these ultra-short-lived particles, physicists can test theoretical models, understand how forces interact at the quantum level, and possibly reveal entirely new physics that extend beyond the boundaries of our current knowledge. But achieving this level of exploration requires extraordinary engineering, beginning with the colossal underground tunnel that houses the LHC's tunnel which spans a circumference of 27 kilometers, 17 miles, is buried at varying depths of 50 to 175 meters, 164 to 574 feet, beneath the Earth's surface. This depth variation wasn't random. It was a meticulously planned engineering decision. The reason? To minimize tunneling beneath the Jura Mountains, which lie to the northwest of the collider. Avoiding these mountains eliminated the need for constructing vertical access shafts, which would have added massive cost and complexity. Instead, scientists and engineers cleverly routed the tunnel through the natural lowlands, reducing excavation costs while minimizing environmental and structural disruption. Additionally, the Earth itself plays a vital role in shielding the collider from unwanted cosmic interference. The crust acts as a natural radiation barrier, protecting the sensitive detectors inside the collider from cosmic rays and background noise that could otherwise distort experimental data. The tunnel was originally constructed between 1983 and 1988 for CERN's earlier collider, the Large Electron Positron Collider, LEP. Later, it was repurposed and expanded for the LHC. Within this ring, 3 parallel concrete-lined tunnels, each 8 meters wide, form the backbone of one of humanity's most ambitious scientific projects. These underground corridors are not just silent passageways of science, they are cathedrals of inquiry, where beams of particles travel at 99.99999% the speed of light, guided by powerful superconducting magnets chilled to temperatures colder than outer space. Every decision in constructing this subterranean marvel was informed by both precision physics and practical constraints. The result is not just a scientific instrument, it's a statement of what humanity can achieve when curiosity is matched with cooperation and ingenuity. The Large Hadron Collider itself traces the border between Switzerland and France at 4 specific points, but the majority of its vast 27-kilometer tunnel lies beneath French soil. Above ground, the surface-level facilities serve as vital hubs, housing critical support systems such as compressors, ventilation units, control electronics, and refrigeration plants, essential for maintaining the ultra-cold temperatures needed by the collider's superconducting magnets. The staggering amount of data produced by the LHC is mind-boggling. Each year, it generates approximately 15 petabytes of data. That's equivalent to thousands of times the entire contents of the Library of Congress. To manage this torrent of information, CERN developed an extensive computing grid network, a vast interconnected system of thousands of computers distributed worldwide. This network allows scientists from hundreds of institutions across the globe to access, analyze, and simulate the data generated from particle collisions. Building the LHC was an immense financial and engineering undertaking. The total cost soared to nearly 7.5 billion euros, making it one of the most expensive scientific instruments ever built. Initially approved in 1995 with a budget of 2.6 billion euros, and an extra 210 million euros dedicated to its experimental apparatus, the project faced significant challenges before finally becoming operational. On September 10, 2008, the LHC was officially launched, but shortly after, an unforeseen setback struck: a magnet quench incident. A sudden loss of superconductivity in the magnets caused severe damage to over 50 superconducting magnets, their mountings, and the vacuum pipes. This mishap forced a 14-month delay while repairs were undertaken, extending the long wait for the collider's full operation. Despite this early hurdle, the LHC's first successful run from 2010 to 2013 revolutionized physics. It achieved proton collisions at energies up to 4 tera-electronvolts, TeV, per beam, and also collided lead nuclei, opening new windows into the quantum world. Among its landmark discoveries was the detection of the Higgs boson, the particle responsible for giving mass to other fundamental particles, a finding that earned the 2013 Nobel Prize in Physics. The LHC also identified exotic composite particles like the bottomonium state and produced fleeting states of quark-gluon plasma, the primordial form of matter thought to have existed just moments after the Big Bang. These breakthroughs marked the LHC as a powerful engine for discovery, forever changing our understanding of the universe's smallest and most mysterious components. Ultimately, the Large Hadron Collider achieved one of its primary scientific goals: to explore and confirm the existence of the elusive Higgs boson. This particle is a cornerstone of the Standard Model of particle physics, a theoretical framework describing the fundamental forces and particles that compose our universe. For decades, the Higgs boson remained purely theoretical. Its substantial mass and complex nature made it nearly impossible to detect with earlier technologies. CERN scientists predicted that if the Standard Model was accurate, the LHC would produce multiple Higgs bosons every minute during high-energy collisions. This capability enabled physicists to finally verify the particle's existence with undeniable evidence, transforming theory into confirmed reality. Beyond the Higgs, the collider has also been instrumental in probing the existence of supersymmetric particles, another speculative phenomena that could extend or even revolutionize our understanding of particle physics. Following its initial 3-year operational run from 2010 to 2013, the LHC underwent a lengthy pause for vital upgrades. The collider resumed operations in 2015, entering its second phase, which continued until 2018. After another scheduled shutdown, it was once again reactivated in April 2022 with enhanced capabilities, including a maximum beam energy upgraded to 6.8 tera-electronvolts, the AV. This third run is expected to last until 2026, promising even more profound insights into the subatomic world. Yet, amidst the excitement of this third run, a mysterious and perplexing event shook the scientific community. An unexpected anomaly that has left researchers searching for answers and ignited concerns among even the most renowned physicists. On July 7, an unusual and mysterious crack appeared within Earth's magnetic field. Unlike a fleeting lightning flash, this peculiar tear persisted for an astonishing 14 hours. This prolonged opening acted like a gateway, allowing powerful solar winds to pour through and trigger intense geomagnetic storms. These storms, in turn, unleashed spectacular and mesmerizing auroras, dancing lights that lit up the skies with breathtaking colors and patterns. Scientists watching the auroras were so captivated by their beauty that many found it nearly impossible to look away. Yet, amid this natural wonder, a pressing question lingered. What caused this sudden crack, and how could it possibly be connected to the Large Hadron Collider? The answer lies in a rare solar phenomenon called a co-rotating interaction region, or CIR. CIRs are enormous plasma structures formed within the Sun's heliosphere, the vast bubble carved out by the Sun's magnetic field and the solar wind. They develop where fast-moving solar wind streams collide and interact with slower ones, creating complex and turbulent regions of energized particles. Much like coronal mass ejections, CMEs, which are explosive bursts of solar material, CIRs are propelled outward from the Sun, traveling through the solar system. However, CIRs differ in their formation and behavior, often lasting longer and having distinct impacts on planetary magnetic fields, including Earth's. As the so-rotating interaction region, or CIR, traveled toward Earth, it carried with it powerful shock waves and compressed magnetic fields. These energetic disturbances spark tumultuous space weather phenomena that often manifest as stunning auroras, ethereal light shows that dance across the polar skies. In the early hours of July 7th, this particular CIR made direct contact with Earth's magnetic field, setting off a sustained G1 class geomagnetic storm. A mild but noteworthy event in space weather terms, according to assessments from the National Oceanic and Atmospheric Administration, NOAA. Analysts also detected a coronal mass ejection, CME, embedded within the solar wind that preceded the CIR, adding further energy and complexity to the solar storm that struck our planet. With the dramatic nature of the magnetic crack and the resulting geomagnetic storm, a vital question naturally arises: should the public be alarmed? Experts are quick to reassure that there is no cause for panic. Fissures in Earth's magnetic field are relatively common occurrences, natural fluctuations in the invisible shield that protects our planet from the harsh effects of solar storms. This magnetic shield, generated by Earth's molten core, serves as a crucial barrier, deflecting charged particles emitted by the Sun and preventing them from wreaking havoc on our atmosphere, satellites and power grids. While many such cracks or openings in the magnetic field tend to open and close quickly, sometimes lasting only minutes or seconds, recent observations reveal that these fissures can sometimes remain open for extended periods, spanning several hours. These prolonged openings allow more solar particles to enter the near-Earth environment, increasing the intensity and duration of geomagnetic storms. However, despite the spectacular auroras and the sustained magnetic crack witnessed on July 7th, scientists emphasize that these events are part of the dynamic nature of Earth's magnetosphere. The magnetic field is not static. It constantly fluctuates and adjusts in response to solar activity, maintaining a delicate balance that has shielded life on our planet for billions of years. Back in 2003, Harold Freyer, the lead author of a pivotal study on this very phenomenon, offered a vivid analogy to help us understand Earth's magnetic shield. He compared it to a drafty house during a storm, with a window left wide open. This image perfectly illustrates how, despite the magnetic shield's primary role of deflecting solar storms, some energy can still slip through the gaps. Much like how a storm blowing through an open window might damage a couch inside the house. In the same way, Earth's magnetic shield typically protects us from space weather, but occasionally energy sneaks through its fissures. These breaches can sometimes cause disruptions, such as failures in satellite operations, radio communications, and even power grids. Fortunately, the magnetic crack that appeared on July 7th did not trigger any such technological failures. Instead, it gifted residents across Canada and parts of the United States with breathtaking displays of the Northern Lights, highlighting the awe-inspiring and beautiful effects of this celestial breach. Adding another layer of significance, scientists have revealed that the Sun is approaching the most active phase of its 11-year solar cycle, a phase that is arriving earlier than previously predicted. This heightened solar activity means we can expect an increased frequency of spectacular auroras over the next 3 years, offering even more opportunities to witness the natural wonders born from the Sun-Earth connection. Meanwhile, the Large Hadron Collider's recent achievements extend far beyond detecting this magnetic field crack. In 2017, the public was introduced to numerous analyses based on the vast data sets collected during 2016. That year marked an intensive period of research into the properties of the Higgs boson, the particle that plays a critical role in our understanding of how fundamental particles acquire mass. Alongside improvements in the precision of experimental results, the Large Hadron Collider has continued to push the boundaries of particle physics. From March 2021 onward, the LHC experiments revealed the discovery of 59 new hadrons based on data gathered during the collider's first 2 operational phases. These discoveries mark a remarkable milestone in our understanding of the subatomic world. A particularly significant breakthrough came on July 2, 2022, when researchers announced the observation of a previously unknown variety of pentaquark, an exotic particle consisting of 5 quarks. This newly identified pentaquark is composed of a charm quark, a charm antiquark, an up quark, a down quark, and a strange quark. This discovery emerged from detailed studies of charged B meson decays, shedding new light on the complex interactions governing quark behavior. However, as is typical in particle physics, the initial rush of groundbreaking results gradually slows down over time. With each passing year, the number of new discoveries diminishes as the most obvious findings are uncovered. To combat this natural decline in discovery rate, scientists have planned significant upgrades to the collider itself. These upgrades aim to increase the collider's collision energy, luminosity, the number of collisions per second, and detector sensitivity. One ambitious plan under consideration is to raise the collision energy to a staggering 14 tera-electron volts LeV, nearly doubling the current levels. This enhanced version of the collider, known as the High Luminosity Large Hadron Collider, HLEHC, began its upgrade process in June 2018. The primary goal of the HLLHC is to boost the machine's luminosity, substantially increasing the chances of detecting extremely rare particle interactions and refining the precision of measurements. By enabling more intense and frequent particle collisions, the HLLHC will open new frontiers for exploring the fundamental building blocks of matter and the forces that govern the universe. Statistically marginal measurements characterize some of the findings in the ongoing 3rd run of the Large Hadron Collider, which serves as an intermediate phase within the collider's broader research program. Each run has progressively deepened our understanding of particle physics. Run 1 was defined by the historic discovery of the long-anticipated Higgs boson, a breakthrough that revolutionized the field. Following this, Run 2 unveiled several significant decay modes of the Higgs boson, further validating its pivotal role as the source of mass for fundamental particles. But what exactly is the Higgs boson, and why does it hold such immense significance in our understanding of the universe? To answer this, we must journey back to the very origins of the cosmos, a time immediately following the Big Bang. The early universe was an extraordinarily hot, dense, and rapidly expanding environment, a chaotic blend of particles, energy, and radiation. As the universe expanded and cooled, a profound transformation took place, the activation of the mysterious Higgs field. The Higgs field is an invisible energy field permeating all of space. As particles move through this field, they acquire mass, a fundamental property that allows matter to clump together, form atoms, stars, planets, and ultimately life itself. Without this interaction, particles would remain massless, zipping through space at the speed of light, and the universe as we know it, with its galaxies and complex structures, would never have come into existence. In this grand cosmic framework, the Higgs boson emerges as a key player, a particle inherently linked to the Higgs field. It can be thought of as a tangible manifestation or excitation of this field, a proof of its existence and function. Scientists often describe the Higgs boson as the universe's answer to the missing piece in our understanding of how particles gain mass, much like the solution to a complex puzzle that unlocks a deeper comprehension of reality. The predicament of conferring essential mass upon all other particles lies at the very heart of the Higgs boson's significance. Yet, its importance extends far beyond simply being a foundational component of the universe. Without the Higgs field, fundamental particles would perpetually travel at the speed of light, making the formation of atoms, molecules, and all the intricate chemistry and biology that underpin life utterly impossible. The very fabric of reality would be profoundly different, rendering our existence as conscious observers inconceivable. In the absence of the Higgs field, fundamental particles would be trapped in an eternal sprint, racing relentlessly at light speed, forever unable to slow down, stop, or combine to create the matter that forms everything we know. This relentless motion would preclude the complex interactions necessary for the universe as we experience it. The discovery of the Higgs boson marked a monumental milestone in particle physics, confirming a critical piece of the Standard Model. This achievement was so transformative that it earned Peter Higgs and François Englert the Nobel Prize in Physics in 2013, recognizing their theoretical prediction made decades earlier. However, the story does not end there. Even as the Higgs boson helped illuminate one of nature's great mysteries, the cosmos continues to harbor profound secrets. Within the known universe, 4 fundamental forces govern the behavior of matter and energy: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Yet tantalizing whispers from the farthest reaches of space suggest the existence of a 5th force, hidden and elusive, waiting for discovery. This mysterious force could potentially reshape our understanding of physics and unlock new realms of cosmic phenomena. Speculation has long linked this mysterious 5th force to the enigmatic substance known as dark matter, an untouchable form of matter that makes up roughly 27% of the universe's total content. Some theorists even suggest that this elusive 5th force could be deeply connected to the existence of extra dimensions, hidden layers of reality beyond our everyday perception. But where can we find the key to unlock these cosmic mysteries? The answer, many believe, lies within the Higgs boson itself. A beacon of hope, much like a guiding light at the end of a dark tunnel, illuminating the path toward new understanding. As the scientific quest for answers intensifies, so too have the concerns voiced by those wary of what meddling with such fundamental forces might unleash. The Large Hadron Collider, the powerful instrument designed to probe the universe's deepest secrets, has become entangled with fears about catastrophic consequences, even extinction. Some imagine the LHC as a hidden gateway to otherworldly realms, capable of opening portals that could release demons or nightmarish creatures into our reality. Others speculate wildly that the collider conceals a devastating weapon, one that could obliterate the planet with a simple flick of a switch. And there are those who entertain even more conspiratorial notions that the LHC is part of an elaborate government scheme designed to manipulate minds, turning humanity into unthinking automatons. Others go even further, claiming that the Large Hadron Collider is engaged in deeply sinister pursuits. These theories suggest that the particle collisions inside the LHC are part of a covert governmental experiment aimed at shaping a new world order, one where only an elite few would survive. At the heart of this apocalyptic vision lies the concept of a false vacuum. A false vacuum is a theoretical state of space where the energy is not at its true lowest level, making it inherently unstable. If the LHC were to trigger a transition from our current vacuum state to a false vacuum, it could unleash a cascade of catastrophic events, potentially obliterating everything we hold dear. While this doomsday scenario might sound like science fiction, the possibility, though extremely remote, cannot be completely ruled out. Some experts argue that the extreme energies produced by the LHC could create conditions conducive to the formation of a false vacuum bubble, which might expand at the speed of light, annihilating the fabric of our universe. The fears don't stop there. The creation of microscopic black holes capable of growing uncontrollably and swallowing entire galaxies is another nightmare scenario tied to these experiments. The profound gravity of such risks has captivated imaginations, evoking comparisons to the infamous snap by Thanos in the Marvel Cinematic Universe, where half of all existence suddenly vanished. In reality, such a cosmic collapse, where the universe itself crumbles into nothingness, is a scenario of immense theoretical consequence, one that challenges and could ultimately revolutionize our understanding of reality itself. Although the possibility of creating black holes within the LHC is extremely unlikely, the potential consequences of triggering a false vacuum transition are so severe that they cannot be dismissed outright. But why hasn't such a catastrophic event occurred yet? The answer lies in the nature of the Higgs field, which plays a central role in the concept of a false vacuum. For the Higgs field to shift from its current false vacuum state to a lower energy, true vacuum state, it would have to overcome an enormous energy barrier through a process known as quantum tunneling. This barrier is so immense that the time required for such a transition to naturally occur is estimated to far exceed the age of the universe itself. In other words, while the theoretical possibility of a universe-ending collapse exists, it is not something that poses any immediate or practical threat. The Higgs field remains metastable, temporarily trapped in its current false vacuum state, allowing the universe to persist as we know it. Meanwhile, CERN continues its ambitious scientific journey. The Large Hadron Collider's third run, which began recently, is projected to continue until 2025, with the goal of doubling the current data collected. Following this, CERN plans an extended pause lasting until 2029 to upgrade the facility. When the LHC returns to full operation after this break, it will be capable of generating particle collisions at a rate 10 times greater than today, ushering in an era of unprecedented precision and discovery. This milestone will mark the beginning of the Large Hadron Collider's fourth run, anticipated to extend until 2042. By the time this phase concludes, the LHC is expected to amass a dataset nearly 10 times larger than that projected at the end of the third run. Looking ahead, the fourth run promises to not only corroborate the theories and hypotheses that arise from the experiments and analyses of the third run, but also to expand our understanding even further. Each run of the LHC represents a deliberate and incremental progression within its overarching program. Every phase builds upon the achievements of its predecessor in an unbroken quest for scientific discovery. Peering into the future, the culmination of the LHC's efforts signals an even deeper exploration of the universe's most profound mysteries. The evolution of the LHC summarizes a story of gradual advancement, punctuated by tantalizing revelations. As it forges forward through its third run and beyond, each collision event contributes incrementally to our collective knowledge. This systematic expansion of understanding offers unprecedented access to the hidden complexities of the cosmos. The third run acts as a critical bridge, linking past experimental triumphs to the uncharted frontiers that await scientific investigation. Although this journey unfolds step by step, its potential to revolutionize our grasp of the universe's inner workings is immense. In this unfolding chronicle of the LHC program, the spirit of scientific inquiry shines brightest, methodically unraveling the cosmos's puzzles through each collision. As we delve ever deeper into the subatomic realm, we edge closer to revealing the universe's most profound secrets. Fueled by the dedication of brilliant minds and the extraordinary capabilities of the LHC, the third run stands as a pivotal chapter in this narrative, laying the groundwork for the insights, revelations, and paradigm-shifting breakthroughs that will define our scientific voyage for decades to come. In the vast realm of space exploration, it is common for the world's most technologically advanced nations to embark on ambitious journeys that reveal the mysteries of the cosmos. These missions continuously reshape and expand our understanding of the universe and our place within it. Among these nations, China has made remarkable progress, especially in lunar exploration. Over the past several years, China's space program has achieved significant milestones that set it apart from other countries competing in the global space race. From landing rovers on the moon's surface to collecting lunar samples and sending back valuable data, China's lunar missions have pushed the boundaries of what is possible in space science. These achievements demonstrate China's growing capabilities and ambitions in space technology. Adding to this excitement, renowned physicist Michio Kaku has brought attention to some groundbreaking discoveries made by China's lunar missions. According to Kaku, these findings are not only expanding our scientific knowledge, but could also pave the way for future advancements in space exploration. As China continues to explore the moon and beyond, its contributions are reshaping humanity's understanding of the cosmos and inspiring a new era of discovery. Join us as we delve deep into these intriguing revelations and examine how China is steadily solidifying its position as a global leader in lunar exploration. The nation's bold ambition to send astronauts to the moon by the year 2030 has captured the attention of space enthusiasts, scientists, and governments around the world alike. This goal represents not only a remarkable technological challenge, but also a significant milestone in humanity, a journey into the cosmos. Yet, China's lunar ambitions are far from sudden or unexpected. For decades, China has nurtured a deep passion and strategic vision for space exploration, with a particular focus on the Moon, this sustained enthusiasm has been reflected in consistent investments in cutting-edge technology, extensive research programs, and a series of successful space missions. From the launch of its Chang'e lunar probes to the historic landing of rovers on the Moon's far side, China has steadily expanded its capabilities and expertise. These efforts demonstrate a long-term commitment to exploring our nearest celestial neighbor and establishing a strong presence beyond Earth. Chinese lunar program is part of a broader vision to advance scientific discovery, inspire innovation, and ultimately secure a leading role in the next era of space exploration. As the countdown to the 2030 crewed moon mission continues, the world watches with great anticipation to see how China's ambitions will reshape the future of humanity in space. China's journey into space exploration spans several decades, rooted deeply in its enduring passion for scientific discovery and technological advancement. As far back as 1964, China took its very first and significant step towards space when it successfully launched its inaugural rocket. This pioneering mission carried an experimental biological payload containing white mice, marking a remarkable achievement in the country's early efforts to explore beyond Earth's atmosphere. The safe return of this biological experiment demonstrated China's growing technical capabilities and set the stage for future, more ambitious endeavors. Building on this early success, China steadily climbed the ranks of the global space race, achieving a series of important milestones that showcased its determination and progress. A defining moment came in 1970 with the launch of Dongfang Hong-1, China's first artificial satellite. This event was historic for not only because it demonstrated China's ability to develop and launch complex space technology, but also because it signaled China's arrival as a formidable presence in space exploration, joining the ranks of the few nations capable of sending satellites into orbit. Moving into the new millennium, China's space program entered an era of rapid advancement. The early 2000s were marked by a number of groundbreaking achievements, none more significant than the successful human spaceflight mission of 2003. With this mission, China became the third country after the United States and Russia, to independently send a human into space using its own indigenous rocket technology. Astronaut Yang Liwei was the pioneer who orbited Earth aboard the Shenzhou 5 spacecraft, demonstrating the country's growing prowess in crewed space missions. His successful journey not only inspired national pride, but also marked a critical leap forward in China's ambitions to become a major player in the international space community. This mission paved the way for subsequent crewed flights and laid the foundation for China's ongoing efforts to develop more advanced space technologies and expand its presence beyond Earth's orbit. Today, China continues to build on these historic achievements as it aims for even greater milestones, including lunar exploration, Mars missions, and the establishment of a permanent space station. Astronaut Yang Liwei spent over 21 hours aboard the Shenzhou 5 spacecraft, completing China's first successful human spaceflight mission. This monumental achievement was soon followed by the launch of Shenzhou 6 in 2005, which carried 2 astronauts on a more extended 5-day mission, marking an important step forward in China's crewed space exploration capabilities. China's ambitions extended beyond Earth orbit as its lunar exploration program reached new heights in 2007 with the launch of its first lunar orbiter, Chang'e-1, just 12 days after takeoff. Chang'e successfully entered the Moon's orbit, beginning a new chapter in China's quest to explore our nearest celestial neighbor. The year 2010 saw the launch of China's second lunar probe, Chang'e-2, which further advanced the country's lunar research and set the stage for more complex missions, including surface exploration and sample return. In 2011, China launched its first space laboratory, Tiangong-1, Heavenly Palace 1, marking another significant milestone. Tiangong-1 enabled China to conduct docking maneuvers and orbit experiments, which are critical for establishing a sustained human presence in space. These experiments paved the way for future space station development and longer crewed missions. China continued pushing boundaries in 2013 by achieving a soft landing of an unmanned spacecraft on the Moon, a feat not accomplished by any country since 1976. This successful mission demonstrated China's growing technical prowess in precise lunar landings and surface operations. Fast forward to 2019, and China reached a historic milestone by successfully landing the Chang'e 4 lunar explorer on the far side of the Moon, the first ever soft landing on this mysterious and previously unexplored side. This achievement marked a significant leap forward in lunar exploration, as previous spacecraft had only been able to observe the far side from orbit without landing. China's continuing lunar missions reveal a bold and methodical approach to exploring the Moon, signaling the country's long-term commitment to becoming a leader in space science. And Exploration Chang'e 4 marked a historic milestone as the first spacecraft to achieve a soft landing on the Moon's far side, an unexplored and mysterious terrain that had remained beyond the reach of previous missions. This groundbreaking mission opened the door to a new era of lunar exploration, providing humanity with its first close-up look at this enigmatic region. Equipped with advanced cameras, sensors, and ground-penetrating radar, Chang'e 4 captured remarkable images and scientific data that have significantly deepened our understanding of the Moon's far side. Among its fascinating discoveries were tiny glass globules, spherical particles formed by high-energy meteor impacts. These glass spheres are not only scientifically intriguing, but also hold practical significance, as they could potentially be used for glass production, providing a valuable resource for future lunar activities and construction. China's ambitions in lunar exploration go far beyond mere scientific study. The country envisions the establishment of a permanent lunar research station by 2035, a project planned in collaboration with Russia. This ambitious lunar base aims to challenge existing programs, including those led by the United States, by creating a complex facility comprising 5 major installations and 9 modules designed to support both short-term and long-term human missions. The planned lunar research station will serve as a critical platform for scientific experiments, utilization, and perhaps even a stepping stone for deeper space exploration. By developing this infrastructure, China is positioning itself as a key player in the future of human presence beyond Earth, setting the stage for sustained exploration and potentially even colonization of the Moon. China's planned lunar base is designed to support a wide range of activities, both on the Moon's surface and in its orbit, underscoring the country's expanding and ambitious role in lunar research. In a move that highlights its collaborative approach, China has also invited international partners to contribute to the development of a lunar communication and navigation system. This initiative is crucial for maintaining reliable contact and coordination during lunar missions and further solidifies China's growing presence and influence on the lunar landscape. Adding expert perspective to China's rapid advancements, renowned physicist Michio Kaku has offered valuable insights into the country's space accomplishments. In interviews, Kaku has praised China's strategic and accelerated approach to space exploration, noting how its progress mirrors the trajectories of historical superpowers in the field. According to Kaku, China's focused investment, technological innovation and long-term vision position it as a formidable force in the modern space race. China's lunar program, therefore, is not only a demonstration of scientific achievement, but also a powerful symbol of its rising status as a leading spacefaring nation, shaping the future of humanity's exploration beyond Earth. Headlining the remarkable success of China's Tianwen-1 Mars mission, a renowned physicist Michio Kaku has praised China's significant investments and rapid advancements in its space program. The mission, which successfully orbited Mars and deployed a rover onto its surface, marked a major milestone for China's interplanetary exploration efforts and showcased the nation's growing expertise in space technology. Kaku's futuristic insights extend far beyond lunar exploration, encompassing humanity's potential for long-term space travel and survival in the cosmos. He envisions breakthroughs in fundamental physics, such as the development of a unified field theory, and advancements in string theory, which could enable us to manipulate gravity, space, and time itself. These scientific developments could revolutionize how humans travel through space and unlock possibilities previously thought to be science fiction. Among Kaku's more imaginative ideas is the concept of an interdimensional lifeboat, a refuge capable of transporting humanity to distant parallel universes as a means of survival in times of cosmic crisis. While this remains speculative, it reflects the visionary thinking driving future space science and exploration. However, Kaku also stresses the critical importance of keeping space a peaceful and cooperative domain. He calls for a revision of the existing Outer Space Treaty to address the new challenges posed by modern space activities, including military uses and territorial claims. Ensuring that space remains a realm for peaceful exploration and scientific advancement is essential for the future of humanity beyond Earth. China's lunar exploration program continues to deliver remarkable scientific breakthroughs. In a joint announcement, the China National Space Administration (CNSA) and the China Atomic Energy Authority revealed the discovery of a previously unknown mineral on the Moon. This groundbreaking revelation marks China's first identification of a new lunar mineral, making the country only the third in the world to achieve such a significant scientific milestone. The discovery was made possible through meticulous analysis of lunar samples brought back by China's Chang'e 5 mission. These samples have provided invaluable insights into the Moon's geological history and offer new clues about its formation and evolution over billions of years. The newly identified mineral, named changesite, Yai, offers scientists a unique window into the processes that shaped the lunar surface and deepens our understanding of the Moon's complex composition. As China's lunar ambitions grow, they are not without their challenges. The far side of the Moon presents significant communication obstacles, as it is permanently shielded from direct radio contact with Earth. To overcome this, China deployed a dedicated communications relay satellite, ensuring seamless and reliable communication between mission control on Earth and its lunar spacecraft operating on the Moon's far side. However, China's expanding lunar goals have also raised concerns on the global stage, in particular the United States Artemis program, which aims to return astronauts to the Moon and establish a sustainable human presence, represents a major point of competition. Both nations are racing to secure leadership in lunar exploration, prompting discussions about cooperation, competition, and the future. Evidence of activities on the Moon. Despite the backdrop of geopolitical competition, China's lunar discoveries and advancements stand as a powerful testament to the nation's unwavering determination to excel in space exploration. From the discovery of delicate glass globules formed by ancient meteor impacts to the identification of new lunar minerals, China's journey across the Moon's surface showcases its deep commitment to expanding humanity's understanding of the cosmos. China's lunar exploration is a story defined by constant discovery, relentless innovation, and bold ambition. Each milestone achieved by the country challenges the status quo, pushing the boundaries of what was once thought possible, while the scientific revelations emerging from these missions continue to reshape our understanding of the Moon and its history. Through these extraordinary efforts, China is steadily carving out its place in the rich history of space exploration. The nation's ongoing endeavors not only highlight its growing capabilities, but also lay the groundwork for future lunar missions that promise to deepen our knowledge of the Moon and open new frontiers in space science. As the mysteries of the Moon gradually unfold, each discovery enriches our collective knowledge of the universe beyond Earth, inspiring humanity to look upward with renewed curiosity and hope. China's remarkable lunar achievements signal a new era of exploration, one that holds immense potential for scientific breakthroughs and the advancement of human presence in space. In the grand tapestry of the cosmos, where galaxies gracefully dance across the vast expanse of space, and stars twinkle like celestial gems scattered across an infinite canvas, there exists a captivating phenomenon that continues to intrigue and baffle both scientists and stargazers alike. This extraordinary phenomenon is known as gravitational lensing. the mesmerizing interplay of gravity, matter, and energy that bends light and shapes our very perception of the universe in ways that defy the limits of our imagination. Gravitational lensing occurs when the immense gravity of a massive object, such as a galaxy cluster or a black hole, warps the fabric of space-time, bending the path of light, traveling from distant stars, galaxies behind it. This cosmic optical illusion acts like a natural magnifying glass, amplifying and distorting the images of faraway celestial bodies. Through this effect, we can observe galaxies and cosmic events billions of light years away, otherwise hidden from view. The study of gravitational lensing not only allows astronomers to peer deeper into the universe, but also provides crucial evidence for the existence of dark matter, the mysterious, invisible substance that makes up a significant portion of the cosmos. By analyzing how light bends around invisible mass, scientists can map the distribution of dark matter and better understand its role in shaping the structure and evolution of the universe. This phenomenon is a testament to the intricate and beautiful ways in which gravity and light interact, revealing a universe far more dynamic and interconnected than our everyday experiences suggest. As we continue to explore and decode the mysteries of gravitational lensing, we gain a richer, more profound understanding of the cosmic web that binds everything together, understanding our journey through the wondrous and mysterious domain of black holes begins with grasping a concept that truly embodies the very essence of their existence: the event horizon. Imagine this as an invisible, cosmic boundary, a point of no return that surrounds a black hole. Beyond this threshold, the gravitational pull becomes so overwhelmingly intense that not even light, the fastest thing in the universe, can escape its grasp. The event horizon marks the boundary between what is known and what lies beyond human comprehension. A frontier where the familiar laws of physics begin to dissolve and merge into a realm filled with unprecedented possibilities and paradoxes. It is here, at this enigmatic edge, that space and time twist into unimaginable forms, challenging scientists to rethink the very nature of reality. Crossing the event horizon means entering a region where classical physics gives way to quantum mysteries, and the fate of anything falling in becomes forever sealed from the outside universe. This invisible veil hides the black hole's singularity, the heart of infinite density and gravity, where current theories break down and new physics awaits discovery. Exploring the event horizon is not just about understanding black holes. It's about pushing the boundaries of human knowledge, unlocking secrets about gravity, quantum mechanics, and the ultimate fate of matter and information in our universe. But as we delve deeper into the heart of this cosmic enigma, we encounter a feature that is even more bewildering and mysterious: the singularity. Picture a point in space where the very fabric of space-time is crumpled and twisted beyond all recognition, a place where gravity transforms into an all-consuming force that distorts the fundamental nature of reality itself. The singularity represents a region where mass and energy are compressed into an infinitesimally small point, creating a gravitational pull so powerful that it defies the boundaries of our conventional understanding of physics and the universe. Here, the known laws break down, and space and time lose their usual meaning, leaving scientists grappling with profound questions about the true nature of existence. As we embark on this cosmic voyage, the story of the singularity is inseparable from the spectacular births of black holes, cataclysmic events that begin with the life cycle of massive stars. When such stars exhaust their nuclear fuel, their cores collapse under the relentless force of gravity, triggering an implosion that crushes matter into the singularity, while the outer layers explode outward in a brilliant supernova. This collapse creates the black hole's defining features, the singularity at its core and the event horizon surrounding it. From this moment onward, a new cosmic entity emerges, an invisible yet incredibly powerful force that shapes galaxies and influences the very structure of the universe. These celestial giants, known as massive stars, are some of the most awe-inspiring objects in the universe. Fueled by the fiery and continuous dance of nuclear fusion reactions within their cores, they blaze across the vast expanse of the heavens, illuminating the night sky with their intense brilliance. For millions, sometimes billions of years, these stars burn with incredible energy, converting hydrogen into helium and then into heavier elements in a complex chain of reactions that sustains their powerful glow and balances the immense forces at play within them. However, this brilliant existence is not eternal. As the star exhausts its nuclear fuel, the delicate balance between the outward pressure from fusion and the inward pull of gravity begins to collapse. The star's luminance gradually fades and enters a transformative phase that ultimately reshapes its destiny. This phase is one of the most dramatic and violent in the cosmos, the death throes of a massive star, leading to the birth of a black hole. At the heart of this transformation lies a cosmic catastrophe. As fusion halts, gravity's relentless grip takes over, causing the star's core to collapse inward with unfathomable force. The core shrinks rapidly, compressing matter into a volume so small and dense that the laws of physics as we know them start to break down. This collapse results in the formation of a singularity, an infinitely dense point where all the mass of the core is concentrated and the fabric of space-time itself is twisted and torn. A singularity is surrounded by the event horizon, the invisible boundary beyond which nothing, not even light, can escape. This marks the birth of a black hole, a cosmic phenomenon of immense gravitational power. The forces within a black hole are so extreme that they challenge our current understanding of physics, merging the mysteries of gravity, quantum mechanics, and the structure of the universe into a single enigmatic point. But the story does not end there. The outer layers of the dying star are violently expelled in a brilliant explosion known as a supernova, briefly outshining entire galaxies and scattering heavy elements across space. These elements eventually become the building blocks for new stars, planets, and even life itself. In this way, the death of a massive star, while catastrophic, also sows the seeds for new beginnings. Black holes born from these stellar giants play a crucial role in shaping the cosmos. Their intense gravitational fields influence the formation and evolution of galaxies, regulate star formation, and may even hold clues to the ultimate fate of the universe. They stand as monumental reminders of the cyclical and dynamic nature of cosmic evolution, a testament to the power and mystery of the universe. Through the study of these stellar behemoths and the black holes they create, humanity continues to push the boundaries of knowledge, uncovering the secrets of the cosmos and deepening our understanding of the forces that govern existence itself. Supreme and awe-inspiring, black holes seem like celestial portals to the unknown, gateways to realms where the familiar rules of physics begin to unravel, and the universe reveals its deepest mysteries. Yet the narrative of black holes is far from uniform. It is, instead, a symphony of diversity, a cosmic performance where stars of varying masses play their final acts with strikingly different and unique flourishes. Smaller stars, like our Sun, bow out gracefully after exhausting their fuel. They shed their outer layers gently and transition into white dwarfs, dense, cooling embers that emit a faint but steady light as they settle into a long retirement. These stellar remnants quietly mark the end of a peaceful life cycle in the cosmos. In stark contrast, heavier stars end their lives with dramatic flair. They explode in cataclysmic supernovae, unleashing powerful blasts that outshine entire galaxies for brief moments. What remains afterward are neutron stars, ultra-dense remnants packed with matter so tightly that a sugar cube-sized amount would weigh billions of tons on Earth. Many neutron stars spin rapidly and are endowed with incredibly strong magnetic fields, sometimes manifesting as pulsars that beam regular pulses of radiation across the cosmos. Then there are the cosmic giants, the supermassive black holes, titans of gravity that command the very centers of galaxies, including our own Milky Way. These colossal entities possess masses millions or even billions of times greater than our Sun, wielding gravitational forces so immense they influence the motion of stars and gas over thousands of light years. Their origins remain one of the greatest mysteries in astrophysics, captivating scientists as they seek to unravel how such massive beasts formed and grew over cosmic time. Together, these diverse stellar endings weave a rich and complex story of life, death, and transformation in the universe. Each type of remnant plays a vital role in shaping the cosmic landscape, fueling galaxy evolution and expanding our understanding of the fundamental laws that govern everything we observe billions of times that of our Sun, play a pivotal role in shaping the dynamics of their cosmic neighborhoods. From their commanding vantage points, These supermassive black holes exert powerful gravitational influence that orchestrates the intricate motions of stars, planets, gas clouds, and even entire galaxies. Their presence shapes the very architecture of the universe, acting as invisible architects of cosmic order amid the vast expanse. Amid this grand tapestry of stars, black holes, and galaxies, a recent discovery has emerged that challenges our understanding of cosmic proximity and the scale of the universe. Enter Gaia BH1, a black hole that resides tantalizingly close to our own cosmic neighborhood, raising profound questions and sparking excitement among astronomers worldwide. Gaia BH1 is remarkable, not only because of its proximity, but also because it was detected in a way that defies traditional methods. Through the subtle gravitational effects it has on its companion star, located just about 1,600 light-years from Earth, Gaia BH1 is the closest black hole ever discovered to our solar system, a silent giant lurking in the celestial shadows. This discovery revolutionizes our perception of black holes, demonstrating that these enigmatic objects may be more common and closer to us than previously thought. It also opens new avenues for studying black holes in unprecedented detail, offering a unique window into their properties and behavior, without the typical violent accretion or energetic emissions that usually announce their presence. As Gaia BH1 quietly influences its stellar companion, it invites us to reconsider the hidden and often overlooked population of black holes scattered throughout the Milky Way. This finding deepens our understanding of the cosmic neighborhood we call home, and underscores the vast mysteries still waiting to be uncovered in the depths of space. Nestled within our cosmic neighborhood, at a surprisingly close distance of just 1,566 light-years from Earth, lies Gaia BH1, a black hole that challenges our traditional perceptions of how near and numerous these enigmatic objects might be. This rudicating process, groundbreaking discovery, not only highlights the vast mysteries that continue to pervade the universe, but also opens an unprecedented window for deep exploration and observation within our own galactic the vicinity. Astronomers have employed some of the most advanced telescopes and cutting-edge astronomical techniques available today to peer into this subtle cosmic dance. Gaia BH1, though invisible to conventional detection methods due to its dormant and non-excreting nature, reveals itself through the delicate gravitational influence it exerts on a nearby companion star. The key to this revelation lies in the phenomenon of gravitational microlensing, a process whereby the gravity of a massive object bends and magnifies the light from a background star, creating a cosmic lens. Through careful and patient observation, scientists have detected the minuscule but measurable swaying motion of Gaia BH1's companion star, a dance orchestrated by the black hole's immense gravitational pull. This motion, invisible to the naked eye and undetectable without precise instruments, is a testament to the presence of the black hole, providing vital clues about its mass, orbit, and the nature of this hidden cosmic partner. The elegance of this gravitational ballet cannot be overstated. In this celestial choreography warps the fabric of space-time itself, bending light in a way that allows us to observe what would otherwise be an invisible cosmic phantom. This interaction not only confirms Gaia BH1's identity as a dormant black hole, but also ushers in a new era in black hole astronomy, one where many such silent giants, previously undetectable due to the absence of accretion disks or X-ray emissions, can now be discovered by observing their gravitational influence on neighboring stars. This method dramatically expands our understanding of the black hole population within our Milky Way galaxy. Instead of limiting discoveries to the few black holes actively feeding on surrounding matter, astronomers are now uncovering a hidden, silent majority that have long eluded detection. Gaia BH1 is the harbinger of this new class of black holes. Quiet, unassuming, yet immensely powerful. Moreover, the implications of finding such a close black hole are profound. It challenges previous assumptions about the distribution and frequency of black holes near our solar system, suggesting that these enigmatic objects might be far more common and closer than previously imagined. This realization prompts a re-evaluation of our cosmic environment, encouraging scientists to look more carefully and with more sensitive instruments for these elusive objects. Ongoing and future observations of Gaia BH1 will provide critical insights into the dynamics of black holy star systems, helping us better understand the life cycle of massive stars, the formation of black holes, and the complex gravitational interplay that governs such binaries. As telescopes and detection techniques continue to advance, we may soon uncover many more such systems, painting a richer, a more complete picture of our galaxy's hidden inhabitants. In essence, Gaia BH1 is not just a discovery, it is a cosmic invitation, a call to explore the invisible forces that silently shape the universe around us. It beckons humanity to push the boundaries of observational astronomy and deepen our understanding of the fundamental nature of gravity, matter, and space-time. This silent giant, lurking in the shadows of our galactic neighborhood, reminds us that the universe still holds countless secrets waiting to be uncovered. The gravitational interplay between Gaia BH1 and its stellar partner is a delicate cosmic dance, a ballet written in the language of gravity and light. Central to this celestial performance is the Doppler effect, a cosmic symphony of shifting colors and wavelengths that reveals the star's intricate waltz around the invisible black hole. As the star moves toward us, its light shifts toward the blue end of the spectrum. As it recedes, the light shifts toward the red. These subtle color changes, like notes in a grand cosmic score, provide astronomers with vital clues to decode the secrets of this extraordinary binary system and understand the nature of their enigmatic liaison. Yet, Gaia BH1 is far from a typical black hole. It belongs to a unique and intriguing class of black holes. that challenge the conventional paradigm. In much of the universe, black holes are known by their fiery disks, the intense X-ray emissions and bright accretion disks formed as they voraciously consume matter from a companion star. These glowing beacons make black holes easier to detect, signaling their presence across vast cosmic distances. Gaia BH1, however, is a solitary wanderer, an enigmatic exception among black holes. It exists quietly, without the radiant companion star that feeds and announces the presence of most black holes. Its silent presence in the cosmic expanse defies the typical narrative of black holes as violent and energetic monsters. Instead, Gaia BH1 is a dormant giant, lurking invisibly and revealing itself only through the subtle gravitational influence it exerts on its companion star. This quiet existence poses new questions and opportunities for astronomers. How many other such black holes roam silently through our galaxy, hidden in plain sight? What can these silent giants tell us about the formation and evolution of black holes? Gaia BH1 opens a new frontier in our quest to understand these mysterious cosmic objects, not through their violent outbursts, but through the graceful and invisible gravitational threads that bind them to their surroundings. As scientists continue to study Gaia BH1 and similar black holes, they uncover not only the secrets of these silent wanderers, but also deeper insights into the fundamental workings of gravity, space, and time. This cosmic discovery is a testament to human ingenuity and curiosity, pushing the boundaries of knowledge and expanding the horizons of space exploration. This groundbreaking discovery profoundly challenges our current understanding of black holes. Those mysterious celestial entities that have fascinated scientists for decades. Gaia BH1, with its unique characteristics, beckons us to delve deeper and unravel the countless cosmic mysteries that these invisible giants hold. It compels astronomers and enthusiasts alike to rethink what we know about black holes and their role in the vast universe. At the center of this cosmic exploration is the Gaia Space Telescope, a true marvel of human ingenuity and technological advancement. Launched by the European Space Agency, Gaia represents one of the most ambitious and precise astronomical missions ever undertaken. Its primary goal: to map positions, distances, and motions of over 1 billion stars within our Milky Way galaxy with unprecedented accuracy. Through its meticulous and continuous observations, Gaia has created a stunning three-dimensional atlas of our galaxy, a detailed cosmic map that reveals the Milky Way's structure. Star clusters and celestial neighbors in extraordinary detail. Within this intricate celestial cartography, Gaia BH1 and its companion Gaia BH2 emerge not merely as isolated points of interest, but as monumental milestones in our quest to understand the universe. These discoveries are guiding lights, illuminating the hidden corners of our galaxy and providing a crucial clue about the life cycles of stars, the formation of black holes, and the gravitational forces at play in the cosmic dance. Gaia's observations allow scientists to detect subtle gravitational effects, such as the gentle tug of a black hole on a companion star, even when the black hole itself remains invisible. This ability to see the unseen has revolutionized the way astronomers identify black holes, expanding our knowledge. Beyond those black holes that reveal themselves through bright X-ray emissions or dramatic accretion disks, as we continue our journey through the cosmos, these enigmatic black holes invite us to look beyond the boundaries of current knowledge. They urge us to peer through the cosmic veil and confront the mysteries lurking in the shadows of space and time. Black holes are not merely destructive forces. They are gateways to new physics, challenging our deepest understanding of gravity, space, and time. Their incredible ability to bend light, distort space-time, and warp reality itself pushes the limits of science and imagination. The study of black holes opens the door to profound questions. How do these objects influence galaxy formation? Could they hold secrets about the origin of the universe? What do they reveal about the fundamental laws that govern everything around us? In essence, black holes like Gaia BH1 inspire humanity to transcend the limits of our current, understand and explore the infinite depths of the unknown. They remind us that the universe is far more complex and wondrous than we can imagine, filled with hidden phenomena waiting to be discovered. Each discovery not only answers old questions, but also sparks new inquiries, fueling the eternal human quest for knowledge among the stars. As we ponder the mesmerizing phenomenon of light bending, a cosmic dance choreographed by the invisible hands of gravity, we are drawn into the grand ballet of the universe itself. The celestial interplay, where photons curve and twist through the fabric of space-time, reveals a universe far more intricate and beautiful than our eyes alone can perceive. Each bend of light, each subtle shift in the starry canvas tells a story of forces both immense and delicate, of matter and energy entwined in an eternal embrace. At the heart of this spectacle lies the enigmatic realm of black holes. Cosmic titans whose gravitational pull warps reality and challenges the very foundations of physics. These extraordinary entities are the only place you can go. From the death throes of massive stars, stand as gateways to the unknown, places where time dilates and space folds. Their silent power and profound mystery invite us to question the limits of our understanding and to imagine realms beyond our wildest dreams. A journey through this ever-evolving narrative of the cosmos is nothing short of a timeless odyssey, a semicircle voyage that stretches across epochs and light years, weaving together the efforts of countless explorers, thinkers, and dreamers throughout human history. It is a celebration of the boundless curiosity that defines humanity, a testament to our relentless drive to seek, to learn, and to understand the vast expanse that surrounds us. With every new discovery, whether it be the gentle ripple of gravitational waves, the silent presence of a solitary black hole like Gaia BH1, or the shimmering glow of distant galaxies, we peel back another layer of the cosmic mystery. These revelations fuel our imagination and deepen our appreciation for the wonders of the universe, reminding us that though we are but tiny specks in this infinite sea, our quest for knowledge connects us to the very fabric of existence. The cosmos is an inexhaustible source of wonder, a boundless frontier that continually beckons us forward. It teaches us humility in the face of its vastness, yet it also inspires hope and possibility. Each star we study, each black hole we map, and each light wave we follow brings us closer to understanding not just the universe, but also ourselves and our place within this magnificent cosmic tapestry. In embracing this journey, we affirm the enduring spirit of exploration that has propelled humanity from the earliest stargazers to the pioneers of modern space science. The story of light-bending black holes and the unfolding universe is not just a tale of science, it is a reflection of our own profound desire to transcend the ordinary and touch the infinite. And so, as we stand beneath the star-studded sky, gazing up in wonder, we join a timeless chorus, one that celebrates the enduring mystery, the breathtaking beauty, and the endless possibilities that lie in the cosmos. Our odyssey continues, ever onward, propelled by curiosity, guided by discovery, and illuminated by the light of the stars.